Institute of Engineering and Technology, Punjab University. He is in the Department of Electrical and Electronics Engineering there, and he has worked in the area of distributed generation and microgrid. So he will be taking 2 lectures in this program. Today, now, and again tomorrow same time. He will be taking a detailed lecture on distributed generation and also on microgrid tomorrow. Okay, so he has several papers in this credit. He is working on smart grid and other projects, live projects also. So I hope your discussion with him will be fruitful. So as we have planned, you listen to his lecture, and then we will have a time of half an hour or 15 minutes for discussion. So all of you write down your questions. At the end, we can ask your questions and have your discussion. Okay, over to Dr. Y.P. Verma.
Thank you, ma'am. So, very good morning, everyone. It's a privilege to have interaction with you. And the topic that Madam has given me today is distributed generation. Our power system has gone a vast change since 1910, when first Electricity Act was enacted, then 1948, and now Electricity Act 2003, which has revolutionized the electric sector. But the reforms that we have in India, it started late as compared to the Western countries and European countries, from where this reform started. And Chile was the first country which started the power system deregulation. And the major context that I will be discussing is on distributed generation. Then we will be discussing about various types of generations, what are the technological and economical advantages, the challenges, and the issues. Because I feel most of the people are the engineering college faculty, and you all must be working towards your PhD, or some must have completed also. So there are a few areas where I think we can have detailed discussions, and you can probably pick up some of the issues for your research also. Now, there are a number of factors which are called, the driving factors for the growth of distributed generation or renewable energy sources. The major factor is environmental concern. Kyoto Protocol, you must have heard, which is in Japan, and the treaty was signed, and European Union had an agreement that they will reduce the emission and encourage the renewable energy sources, and even reduce the demand also. The recent summit in Paris, you must have heard, that is also a big challenge, and India is the signatory now. And we know that in India, the thermal generation is the prime source of energy, and more than 65 or 70% of our generation is from the thermal sources, and it also leads to a huge emission. And once we are a signatory to this treaty, then we need to cut down that emission. And if we cut down the emission, obviously we need to look for some alternative sources of energy. So there comes this concept of environment, distributed generation. And in addition to this, we also have technological advancement, and with the help of technological advancement, we are in a position to use efficiently the technology, the fuels, cheap fuel opportunities, whether it's renewable energy sources like wind or the solar. Obviously we have a long way to go, but still we have developed the technology that we are in a position to harness those energy sources. And no doubt they are green in nature, so they are preferred as compared to the sources which cause emission. Another big factor, that is electric market liberalization. I told you that it started in European countries and Western countries long back, but in India, after Electricity Act 2003, number of policy initiatives have been taken. And one of the major policy initiative is that generation has been made license free, and that means that you need not to take any permission, particularly if you want to set up your on generation, whether it is from renewable sources or your micro or some other sources. So you have that flexibility. The second is that because of restructuring, there are number of market players which have come into picture. Obviously, it has increased complexity, but with technology, we are in a position to at least manage the whole system. In India, if you see that Power Grid Corporation of India Limited is managing number of such affairs, and as a result of that, we are in a position to encourage those renewable energy sources. And the policy initiative, if you see, in policy initiative, the government has taken a number of such initiatives, such as feed-in tariff. Then we have net metering system, renewable purchase obligation to encourage renewable energy sources. So government or market liberalization has provided those opportunities. In addition to that, if you see that these renewable energy sources or the distributed generation, they are helping us in in use when we need them, during peak hours. Then reliability and power quality is also an important issue in the power supply. So that is also being maintained with liberalization. And the market mechanism has ensured that the power that is supplied is reliable in nature, it is of good quality. Then this uncertainty in the electricity market, it also favors smaller generation techniques, because electricity boards, they have not been disintegrated. Now it's a market, and the market players are coming into picture. So if we have the resources like solar, wind, they are having very negligible operational maintenance cost. So obviously, if there is uncertainty in market, so these are very useful in the sense that you need not to invest any money as far as the generation is concerned, and you can provide it and you can expect good return in from these powers. Similarly, the expansion or use of local network grid, that is also a big area or the initiative that is at present, that we are encouraging, that rather than using generation at different points, it's better to form a small grid which also can meet the local need and can also support the main grid. So these are some of the opportunities that is being provided by the electricity market after this Electricity Act 2003. Now I think there is Electricity Act 2015 coming up. So you will find many more initiatives for the clean energy sources. Now let us define what does distribution generation means. This is basically a generation which is very close to load center, and it may or may not be connected to the main grid, but definitely it should be connected to a distribution system locally. So it is electricity production that is on site or close to the load center, and it's interconnected to the utility distribution system. This is the basic definition of distributed generation. And there are many more terms which are used for distributed generation, like dispersed generation. Obviously, it is scattered. The availability of these resources, it depends upon the location also. Like if we talk about the wind energy sources, obviously it is more in the coastal areas. Tamil Nadu, that meets 30% of its energy from renewable energy sources like wind. Then if we talk about the Gujarat area, they also have sufficient wind potential. The solar potential is quite high in Rajasthan, in many parts of the country, and particularly if you see Leh and Ladakh, they have huge solar potential because of the environment over there, that they get almost 300 days, sunny days in Leh and Ladakh. So it is dispersed. Similarly, if we talk about thermal generation, magneto hydro generation, so they all are dispersed. They are located at different locations. Similarly, this another term is embedded generation and decentralized generation. These various terms which are used in different papers for distributed generation. Now, the basic definition that I told you earlier also, that it is a small scale generation. When we say distributed generation, we cannot consider the thermal sources which are having megawatt capacity or maybe 100 megawatt capacity. It is generally those generating sources which are having low scale generation up to a few megawatt. I will give the detailed description about the definition which have been given by various agencies. IEEE defines the generation of electricity by facilities sufficient some other than central plants. So this is what IEEE defines as far as the distributed generation is concerned, and it allows the interconnection at any point. So means point of interconnection of those resources is not at a particular location. It can be close to a load center. It can be in a load distribution network also. It can also be to the main grid. So distributed generation, as I told you earlier also, that is also called as on-site generation, distributed generation, district energy, and it generates electricity from many small energy sources. So there are various definitions which have been given. And there are a few standard institutes like EPRI. They defines distributed generation on the basis of its generation capacity. Like if generation is ranging from few kilowatt to 25 megawatt, then this is called as a distributed generation. Similarly, GRI is also keeps the limit between 25 kilowatt to 50 megawatt. Then Cardial define this from 500 kilowatt to 1 megawatt, and SIGRE define distributed generation below 100 megawatt. So various agencies have different criteria to define distributed generation, but the fact remains that most of these sources which are contributing to the generation is clean in nature, and they are scattered, they are distributed, and they must be most probably closer to the load center. The reason for keeping them closer to the load center is that if the capacity is not large, so it becomes very difficult to install the transmission network for those, because it needs environmental clearance, it needs huge cost also, and moreover the energy sources which are of variable in nature, if they are not reliable, then it is not advisable to invest such a huge money. That is why the concept of local generation or local grid like microgrid has also come up. The generation capacities that we define, we can say the micro DGs, they are from a few watts to the 5 kilowatt. Then this small distributed generation, they range from 5 kilowatt to 5 megawatt. The medium range distributed generation, they range from 5 megawatt to 50 megawatt, and we say that it's a large distributed generation, so they range from 50 megawatt to 300 megawatt. See, in distributed generation, besides solar, wind, geothermal, tidal, we also have micro hydro. Micro hydro is also it also falls in the category of distributed generation, and if the capacity is of few megawatts, so they can also be they are also categorized under this category. Now, when we define the distributed generation, there are so many issues that has to be considered. The first is the purpose. For what purpose this generation is there? Whether this generation is supplying your active power, they are supplying your reactive power. So the purpose is important. Like fuel cell, they supply only the active power. So it is also defined on the basis of the purpose, the location, where it is located, whether it's close to the load center or somewhere else to which area it is supplying. That is another important factor on the basis of which distributed generation is defined. Then we have the rating of distributed generation that I already told you, that it's small, then your micro, and then you can be your large distributed generation. So rating of the power generation is also another important factor which is used to define the distributed generation. Then power delivery area. Generally, the distributed generation is considered that it should supply the power locally, because I already told you that it is difficult to have that transmission network for that if it is located in a far off area. So it is better that we have these resources which are closer to the load center. So delivery area is also important area or issue which is used to define the distributed generation. The technology, which technology is used? I told you we will discuss about the technology, solar, PV, wind, geothermal, hydro, okay, fuel cells. So all these are the technologies which are there to generate the power from the sources. The mode of operation, that is which mode, whether grid connected, isolated mode. These are also used to define the distributed generation. The ownership, which is the owner of that, whether it is fully public, the private, or public-private partnership. So on the basis of that also we define distributed generation. Then penetration of distributed generation. What is the amount of contribution by these sources? That is also one of the areas, one of the factor which is used to define this. Then the planning issues. The planning issues, whether you can include these to the existing lines where you need additional line for that, because if we see that the penetration is large, and if we connect them into the existing lines, that may also lead to number of other challenges, like whether quality of the power is fine, or the congestion, the capacity of the line is sufficient to carry the power generated by these resources. So these are also some of the areas which have to be considered while defining distributed generation, and they have been considered by various authors in various papers. The protection scheme, which protection scheme should be used for that? The cost and cost recovery issues. See, there are a number of energy sources which are there, and obviously if you see the capital cost of hydro, that is very high, but running cost is very small. Similarly, if you talk about the wind and the PV also, the capital cost is still very high. Obviously the technological development is going on and it may come down, but whether cost recovery is also there. So feasibility is no doubt there, but whether it's viable or not, that is also a factor which have to be considered while defining this distributed generation. Interconnection agreement. I told you that liberalization has electric market concept has provided this. So what are the agreements? Whether it provides ease to interconnection, can the generation be easily supplied to the load centers? Whether the policies, the grid code, they provide you that opportunities. So these are some of the main factors which are used to define, or they have been used to define the distributed generation by various authors, various electricity markets, in various papers in the literature if you'll find. Know the generation technologies which are which fall under the category of distributed generation. Obviously windmills. We know that we have windmills of various capacity. There are vertical axis windmills. We have horizontal axis windmills. So they are dependent upon their location, the locational advantages. In few areas we prefer vertical windmills, and few areas we prefer the horizontal axis windmills. Then we have the photovoltaic and solar thermal. Photovoltaic fact we can see everywhere nowadays, whether it's street light or in major buildings, we are encouraging photovoltaic. And solar thermal is also one of the areas which is being which are promoted long back, because you must have seen the solar geyser at your home, but it's not only for domestic purpose nowadays. So solar thermal is also being used to run turbines also. So there have been technological development with the help of which that we are in a position to generate heat from the solar sources, and ultimately that heat is used to drive the steam turbine. And already in India we have 1-2 projects near Gurgaon in National Institute of Solar Energy, where 1 megawatt solar thermal wind turbine is used. Then micro turbines. Micro turbines are also being used nowadays. We have natural gas. There are options that we can have small turbines. They can be used as in where, because it doesn't need any environment clearance because of the gas that we have, and it can be easily installed at a location particularly if we have a small industry, if we have a small organization like an educational institution, if they have sufficient space, and they can be easily installed. Then fuel cell. The fuel cell is having number of uh, applications, and there is lots of development going on in fuel cell. Till they are polymer based now, nanomaterials are also being used. The biggest challenge that we have in this is of the storage. So I think with nano, the batteries will also be developed, and the fuel cell will also have higher efficiency. That they are the major source as far as generation technology in renewable this distributed generation is concerned. Then biomass and biofuels, they have been used. They are being used now in bulk. So it is also a best way to dispose of our the waste. Then geothermal, obviously they are located at different areas, so we need to harness at that particular area only. Then tidal ocean, obviously at the coastal area only. Then reciprocating engines. Storage is another which we say is also can be called a generation technology. In storage, we do have batteries. The batteries there are lots of development going on lithium-ion batteries which have come up nowadays, uh, but still we are not in a position to use complete generation, and we are not able to generate a battery which have very huge capacity. So in many market in European countries, there are electric vehicles, so they are using electric vehicle for storage purpose also. Then we are having ultra capacitors. Then super magnetic energy sources. Then we have flywheels also to store that energy. In addition to that, we can also use this combined heat power and interruptible loads. Interruptible loads, though this is not a generation technology, but yes, there is a provision that in case you do not have sufficient generation, you are in a position to cut down your load. So this might be because of market mechanism. This has also come up, and we are in a position to change our demand based on that.
So could you please elaborate the reciprocating engines? What are
Reciprocating engine, I will discussing further. I will let you know about this. Now, these are few pictures of micro turbines. Then we have fuel cells, solar thermal, and photovoltaic. These are two different effects. Then we have geothermal and tidal power. So these are some resources. Then the DG types. I already discussed about the technologies. Then we have the traditional and the non-traditional. In distributed generation, the traditional generators are micro turbines. The micro turbines are not only driven by the natural gas turbines, which are based on simple cycle and combined cycle, but in addition to that, there are mechanism in few of the case studies where in long towers, even the distribution, water distribution uh, is also being used to drive the micro turbines. So they are also being used. See, there are a number of options people are looking into as far as these micro turbines are concerned, that how can we generate power. So the distribution of the water will also be there. In addition to that, we can also generate some power. Similarly, if we talk about a non-traditional, in non-traditional we have first the fuel cell technologies. I heard detailed characteristics of those discussion that we'll talk about that later on. And I told you that we have polymer based the fuel cells. Then for the storage devices, the flywheel, they are being used for the storing purpose. Then batteries, different type of batteries are also being used. And under renewable, we are using photovoltaic and the wind for that purpose. Now, if you simply compare the centralized and distributed generation, in central generation, what was there, that we were having central plants, whether it's your thermal, your hydro, then they were generating power at certain voltage level. It is being stepped up, then it is being transmitted, okay, and then stepped down and then distributed to the various load center. But in distributed generation, now we can have these micro turbines. I told you that micro turbines do not need any specific location. It can be installed anywhere. Then wind, obviously, it needs certain potential, but nowadays, there are options available that we have low wind speed turbines also. Vertical turbines or exit turbines are mostly used for that purpose. Solar obviously is a huge potential everywhere. I think most part of the world and the country. The fuel cell, obviously, that can also be used. and few of your demand can be locally met. If you see, particularly in cities like Chandigarh, where because of the policies, we are in a position to generate power through for, solar or maybe any other sources, and we have the net metering system in place, and this is already implemented, and in case you have any surplus generation, you can meet few of your demand, and in case you want to supply to the grid also, that there is also a provision. So that policy initiative has been taken, and the important part in that case is that you are getting that money in return, and that is slightly more than which what you get from the conventional sources. So that is what is the biggest advantage with this. So it can be locally met. This is what is your mm, characteristics of various generating sources. I think it must not be very clear, but there are some internal combustion technologies. Then we have fuel cell technologies and the storage technologies. The various characteristics, uh, they are size. Then we have the size. If you see the reciprocating engine, they range from 30 kilowatt to few megawatts. Then micro turbines, they are up to few kilowatts only. Then combustion gas turbines, obviously few megawatts. Then fuel cell, they are not of very high capacity, so they are generally in the range of the kilowatts. So they depends upon the technology where it's used, whether it's your proton exchange membrane, phosphorus, then even polymers are based also used. Then storage technologies, then they are also limited. They are also limited, and lithium ion is the best technology right now for storage purpose, which have the capacity of a few megawatts. Then the power density. The power density, because the size is also is a big factor, because how much space that you occupy. So that also is decided based on the power density. So these are also one of the characteristics that must be kept in mind while deciding the DG technology which you will be using. The temperature where it should be used. There are few areas, particularly if you see the storage technologies and the batteries. If we see the Leh Ladakh area where temperature is very, very less, obviously in those areas the storage becomes a challenge. The batteries, they get discharged, they get freezed, and it becomes very difficult to operate them. So those technologies should be avoided in those areas, or we need to come up with some solution where those can be easily used. So this is what that is why the technology characteristics are also important as far as their placement and all this is concerned. The startup time, very important, because load keeps on changing frequently. Plus, if there is an outage of line, outage of a generator, whether your technologies are able to meet your load change or not. And we need to see in this context, because if the outage of a generator of a thermal which is of few megawatts, and these resources that we have, they are of very smaller capacity, so whether they all are able to meet within a stipulated time, that is very important. So we also call that as the ramp rate limit, where they how much time they take for the startup of that. Then the efficiency, obviously efficiency is a big challenge, and most of these, whether it's a thermal, if you see the our normal thermal generation, or maybe the turbines, the fuel cell, or even storage. In photovoltaic also, the efficiency is very poor nowadays. So there is technological development is needed, that we come up with some new material where the efficiency of photovoltaic is quite high. Similarly, the wind, because under various conditions, should be able to operate. So the control mechanism need to be developed for that also. There is already work going on. So then, combined electric and thermal capacity (CHP). So that is also being used. That the heat is also being used for, heating your areas like hospitals and educational institution. So that is also combined efficiency is also given. Then the installed cost, how much is the installed cost? That also should come down. So earlier, if you see the photovoltaic with the per watt cost was quite high. Now it has come down drastically. Plus, government is also providing subsidy, which also gives encouragement to this. Then operational maintenance cost. So all these are the few characteristics of various technologies which are there, and they must be used. Then let's talk about these the barriers in adoption of distributed generation. Contractual and technological interconnection requirements for protection devices. See, grid code has to be ensured that the power quality need to be ensured. One of the factors that was a barrier here in Chandigarh as far as that metering was concerned, that there was no expertise as far as the power quality of the generation is concerned, that whether power quality generated from the renewable sources is at the home is of better quality or not. So that those interconnections, those grid codes has to be ensured. So these are, if they are not in place, there is not sufficient technology, manpower available. So it becomes a barrier to the adoption of the distributed generation. Then the contractual obligations is also there. So in particularly in renewable resources in distributed generation, they are variable in nature. So we cannot expect them to deliver as and when needed, because mostly they should have priority dispatch, or when they are available they should be used. But if there is a contract, it becomes very difficult, because if the wind is not available, it becomes very difficult to generate from that. So these are some of the issues which need to be resolved, and because of these factors, it becomes essential for these renewable sources to work in combination. The hybrid system has to be developed for that purpose. Then in few areas there's some surcharge are imposed by utilities on DGs, okay, for standby services. That is also a loss to those operators, so that is also discouraging them. Then pricing. So nowadays the pricing is no doubt quite high, but if it is the average rather than the marginal cost is obviously needed to sustain in the market, because the capital cost of these resources is quite high. So they need to be provided. Similarly, environmental permitting requirement of local government. So obviously there are some environmental clearances and permitting needed, but Electricity Act 2003 has waived off many things. So in those cases, if the generation is from the photovoltaic, or maybe wind or fuel cell, or maybe the biogas, so there is no such restriction from the local government, but for few plants it is needed. So these are few barriers which are there for the adoption of distributed generation. Now another important point that is there is the power quality issue, because I told you that in net metering system which was adopted in Chandigarh, where there were few houses which already have installed solar panels and they were ready for the net metering system, but they were not able to ensure that the power which is generated is of required quality or not. And obviously there is variability concern. There are a number of technologies in the sense that we are having power electronic devices also being used for the control purpose, which are also leading to certain harmonics, whether there is sufficient amount of filtering done or not. Because if you are introducing harmonics into the system, and obviously if you are using it for your own purpose, that's not an issue, but if you are using it, if supplying it to the grid, it also leads to a bigger problem, if it is of large in capacity. So one of this the major issues was the voltage regulation. So the over voltage due to reserve power flow. If the downstream DG output exceeds the downstream feeder load, there is an increase in the feeder voltage with the increasing distance. That is one major concern. And if the substation and voltage is held near the maximum, then voltage downstream on the feeder can exceed the acceptable range. So this is one major concern with these resources, that where so optimum location of distributed generation has to be ensured, so that there is no problem of the voltage regulation. Then DG grounding issues. So it did grid connected DG, whether it is directly or indirectly connected through a transformer, it should have effective grounding, because during even in unfaulted phases, the overvoltage during single phase to ground faults. So there can be voltage variation. So if it is properly grounded, so if you are installing any such sources, whether they are properly grounded or not, that need to be ensured. Otherwise, it can lead to yes, power quality issues. Then harmonic distortion. I told you that we are having number of nonlinear loads. Then we are having power electronic devices, okay, which are used to control, and because of that, we need to see that if we are in addition to that, communication devices also there. So harmonic distortion is also a big challenge with these distribution sources. The islanding. Islanding is basically disconnecting the sources during any disturbance. So it's better to isolate that faulty section and operate it at and the this area which is not at fault separately. So it occurs when small region of the power grid is isolated by broken lines, and yet local sources provide enough power to keep voltage up. So means you can separate out it your local need. It is being met by your energy sources only, and you are able to maintain that sufficient voltage level for that. And in case the DG is a distribution system capable to meet a load demand, DG can be operated in island mode and continue to energize the distribution system. So mostly in areas like Leh Ladakh particularly, it is not advisable to install those transmission line for long large number of transmission line. So there there is a few lines only which are used for carrying out transmitting that power, but there is an option that they can be used in islanding mode most of the time, and as and when needed the grid can also supply. So that is another point. The challenge is another challenge is the intermittent nature. We talked about that most of the power is being contributed by the photovoltaic and the wind energy. So they are variable in nature. So variability has to be countered. So how to counter that? The best practice is that that you should have effective load forecasting or even the wind forecast for that purpose, and you should have some backup in place. So that is and in addition to that, the wind speed, if it is slightly varying, you should have effective mechanism, control mechanism in place. So there is some mechanism already in place which are there. This can also be resolved by using large sufficient storage. So obviously the batteries, if they have a high capacity, they need to be used, but how efficiently they can be used, so obviously that mechanism has to be developed for that purpose. And if the capacity is quite large, so obviously space required for batteries is less. And if we see the European countries, particularly what they have developed, the idea is that they are having number of electric vehicles. So rather than using the separate batteries for storage purpose, they are using electric vehicles, and they are used for storage. And those who are idle at night, they can be used to meet emergency needs. So we need to take care of that environment nature, because it is not in our control to a certain extent. No doubt it's free, but obviously it's not always usable. Wind speed can be very high sometime, so we need to shut down. We cannot use it. It can be very less also. So there are some options, some hurdles in this. It deteriorates the system stability. Obviously you have a mechanism in place with the help of which you can provide that control, but it is sometimes it becomes very difficult. And particularly if we talk about the stability, it decreases the system inertia. The system inertia is mostly supplied by the thermal and hydro sources, and they are not able to provide that kind of support as and when needed. And particularly if you see the wind sources, wind sources, we also require the reactive power. Obviously capacitors are being used for that purpose, and in those cases where or in the systems where the generation from these sources is of large magnitude, and if they all
gets disconnected suddenly, or they are not able to supply sufficient power, the system inertia will go down. That will decrease the frequency. Frequency will ultimately result into losses, the load change, and load change will further decrease. And this will, be a factor which will be multiplied, and ultimately it can lead to the system instability. So that is also another challenge which is there. Less efficiency. I talked you already about this, that if we talk about the photovoltaic, we are not in a position to develop the photovoltaic which is having efficiency more than 20% till date. So if that ultimately it lead to a large space. Okay? So that becomes a big challenge, and particularly in solar, the maintenance in terms of that, we need to see the optimum location of the wind solar panels. Their inclination is also another area which to see. It also is affected by the dust. So that is also, it need to be cleaned. If it's a large area, spread over a large area, it need to be cleaned. So there are so many things which are there with these systems, which result into lesser efficiency. Voltage regulation problem, we already have talked about this. Okay? Less predictable load pattern. So load till now, what we are not nowadays with restructuring, the best part is that now each and every state has to provide the load and generation schedule well in advance, 24 hours ahead. But despite that, the load keeps on changing quite frequently, and because of that, uh, whether you're solar or maybe wind, or they are able to supply as per the change in the load or not. That is also a challenge, because if suddenly, let us suppose, if load is high, wind is less, so obviously generation is less, we need more generation at a time. And there can be a situation like this when load is less but you have sufficient wind power. So what to do in that case? In case you have provision for the storage purpose, obviously use it. If you do not have a storage purpose, you need to disconnect it. Another problem with this is that if you are supplying it from the thermal resources, in thermal resources, if you have, let us suppose, wind power, obviously priority dispatch is given to the wind power. But in that case, you need to reduce the thermal, and sometime maybe it has to be shut down. But the startup cost of thermal is very high. So all these factors have to be seen while deciding whether when or how to use these distribution generation. So these are some of the challenges, and they are being managed by very effectively by transmission system operator in India, which is a subsidiary of Power Grid Corporation of India Limited. And changing revenue pattern. So even subsidies also, if you see the subsidy which were provided for the photovoltaic earlier, now they are being cut down slowly. So that also becomes a discouraging factor, a challenge for the people who are ready to invest at this stage. Now some of the applications, if you see the standby, few areas like in the industries and hospitals, we always need a standby for this. So DGs can provide that, particularly the fuel cells, their storage where we have, so they can easily supply that. Then the standalone job, I told you a few areas. Maybe if we talk about the areas like Rajasthan, where we have huge desert, or the few areas like Leh Ladakh, where or the coastal areas where it's very costly.
Hello. Hello.
Hello. Yeah.
Hello. Sorry to interrupt you, sir.
Yeah.
I am from Modi University.
Yeah.
Sir, regarding this barriers in adaptation of DG, I have little doubt that grid codes are there. So these grid codes are same for solar and wind both, or there is a separate grid code for solar and wind like?
No. The grid code is same. Grid code is same. You see, if we talk about the wind also, so in wind, there are controllers available. We are able to get the sufficient voltage level and the frequency from that. The barriers, when I say the barriers, is that there is fluctuating nature of these resources, and we need to have effective control. I told you that wind can generate from a fixed wind speed from 5 meters to 15 meters per second, if it is at a height of 80 meters. So the wind speed can be very high sometime, it can be very less sometime. So what I mean to say is not that they are not supplying the required voltage level or the frequency. Obviously, grid code has to be ensured. But the problem is that in case the wind speed is very less or it is very high, in those cases it becomes a problem, and we are having a variable nature of the load. That is what I said is the problem with these resources.
Sir, for solar also there are grid codes, certain like winds.
Yeah, obviously, you see in solar, obviously the problem with solar is not that much as as the case of the wind. Obviously, in solar, what we do is generally there are two ways to connect it. One is we can directly connect it to the grid, or the second way is that we can store it through batteries and convert it through inverters, and it can be supplied. So obviously, there is a grid code which ensures that what's the voltage level, how much should the harmonic available there. So these are well in place. So the question which I think I think there is a confusion in that. The point which I was trying to make is that the wind and the solar energies, they are unpredictable in nature. They cannot be ensured as and when we need it. But as far as the quality of the power is concerned, when which we connect to the grid or which we supply to the consumers, that is always ensured by grid code. We do not allow that much poor quality to be connected into the system.
Sir, one more question I have regarding the system stability.
Yeah.
Since we install the solar PVs at the distribution side, so whether the stability is important from distribution side also, or it is concerned with the transmission side only?
See, as far as the stability part is concerned, obviously it is affected. No doubt, it is mostly concerned about a generator, and in particular, if you see the frequency, which is who maintains the frequency. Frequency is being maintained by thermal generators, which supplies which when we say that a generator is rotating at a particular speed, so it ensures that it supplies a particular frequency. The moment load changes, load increases, let us suppose, frequency will go down, and we need to increase the generation at that particular point of time. So if we see distributed generation like wind, if most of the power is supplied by the wind or the photovoltaic solar, then in case they are not available, then what happens? Those generation which is supposed to be supplied by those resources, now that load will come onto the main thermal generators. That frequency will go down. Obviously, there is we need to go for load shedding in that purpose, in that case. And another important point which you are trying to which you make is that transmission, from the transmission line point of view also, it is important in the sense that if you connect any renewable resources at a particular location, it may lead to overloading, it may lead to congestion. So that can also lead to a problem in that case. And at the same time, if we see, we already talk about a voltage regulation, that where do you place your distributed source, that can also lead to the voltage. So voltage stability is also a bigger challenge in that matter. So it is concerned whether it's to all, whether generator, even transmission, or even distribution also.
Thank you, sir.
Yeah, and anything else?
No, sir. Thank you, sir.
Yes. Okay. So we were here at the applications. So I told you that standalone, like where it is difficult to have transmission lines, we can go for the standalone system. Like we can have solar panels over there, we can have wind, we can have hybrid system, and the concept of microgrid is because of this only. This peak load shaving, obviously that if demand is high, and we are having those storage available, they can be supplied as and when there is peak load. And particularly I will be talking about one concept here, that during peak load the energy charges also go up in case frequency is different. So in that case you can also lead to more cost saving, or maybe revenue in return. Then rural and remote application microgrid, I already talked about that. We can set up the microgrid. Then we are also having an option for combined heat. Cogeneration options are available. Then the base load, and in few cases they can also be used for the base load supply. They should be getting the priority dispatch. I talked about earlier that wind and solar should be used as and when available. So they should be given priority dispatch. Maybe you need to cut down your generation from the hydro or some other resources, and because they are not giving us or charging any. We do not need to have any cost for the generation. So they also, and particularly the losses also reduces. If we are generating power at a load center, obviously there is a huge amount of transmission loss which takes place. So that transmission loss get reduces because of that. And another important application in that case is ancillary services. I will be discussing it in detail, that they can, few of them can also supply the reactive power and reserve. So as and when needed, they can also be used for the reserve purpose. So these are few applications which are there for the distributed generation. Then this policy initiative which are there for distributed generation. So the first point is the uniform grid code. So the code is uniform, that we were discussing just now, that every generation they need to follow it, because the power quality has to be ensured. The second important policy initiative is of renewable purchase obligation, and this is also called RPS. So in this case, each and every state is asked to generate power from renewable resources to a certain extent. So I think in India it's up to 10% till date, that each and every state has to meet their generation from renewable sources. And particularly in states where there is no, or maybe very limited options, then they have to purchase that power from the producers which are which are generating power from the renewable energy sources. And those generators, those power producers, they need to get renewable energy certificates. So these certificates are issued by an authority, and particularly they are issued to those power producers which have a generation capacity of minimum 1 megawatt till date. And once you have the renewable energy certificate, so any state who is not able to meet its renewable purchase obligation quota, they can purchase power from that at a certain rate. And obviously this net metering system is being used, so you can this system is in place nowadays, and you can generate power from renewable sources. You can meet few of your demand, and you can also directly connect it to the grid. If you are connecting it to the grid, so you are getting feed-in tariff. The charges is generally, I think, for solar power, particularly in Chandigarh, it is 8.50 paisas at present. So if you generate 1 unit of a solar from solar power, you will be getting this much revenue. Then the concept of ABT, it has also started in 2005 in India, availability based tariff. This is a big concept for maintaining the grid discipline, and it also ensures that distributed generation come into picture to support the frequency, which also helps them in cutting down their cost or earning the revenue. So in this case, in ABT concept, if you see, the risk curve has slightly changed now. The frequency range is now from 49.7 to 50.2. This is a old graph. So you can see this, the frequency and UI rate. UI is unscheduled interchange rate. I told you that each and every state, they are asked their dispatch schedule well in advance, and that is called as a scheduled interchange, SI. So they are getting that money based on their generation for per unit. But in addition to that, in case the frequency is somewhere deviating from 50 hertz, based on that, if you are deviating from your schedule, let us suppose a particular state, if they commit to schedule 50 megawatt generation, and they are not able to meet 50 megawatt generation, then they will be charged a UI rate. Or in case the load is high and some generator or some state is ready to supply more generation, so for additional generation, other than the normal prices, normal charges that they get, they will also be getting additional revenue, which will be decided based on the UI rate. So it depends upon the frequency. So what happens in case the frequency is less? In that case, it is an encouragement for generators to generate more, so that they can maintain the frequency close to 50 hertz. In another way, the demand centers, the load center, right? There was a term called interruptible loads earlier when I said DG technologies. So load center can also reduce their generation, their consumption, and as a result of that, generation can be made equal to the load. So this availability based tariff concept is unique concept in India, which is which is adopted, and it ensures that grid discipline is maintained, and the charges, the penalty is quite high. Few states, if you see the previous blackout that took place in India, there also there were few states which were overdrawing power other than the normal schedule. The problem with the Indian states in few is that it's not only the management issues. There are some political issues that, particularly in seasons like paddy season and some other seasons, where there is a huge demand of power in states like UP and Punjab, where the paddy is grown. So even if you should commit some power, and if you're consuming more, you are given warning that do not consume more, but still they use more because under the political pressure, but they are ready to pay the UI charges for that. But in those cases, there is the chances that it can also lead to grid instability. But otherwise, it is being monitored very closely, and it is an encouragement to the generator sources as well as to the demand centers that they schedule or reschedule their generation and load respectively, so that they ensure the discipline. At the same time, they can also earn the revenue in return by changing their schedule.
So what's the full form of this acronym?
UI is unscheduled interchange rate. I told you that there is day-ahead market. Each and every state, there is, we are having load dispatch centers, the central load dispatch center. Then we have state load dispatch centers. So state load dispatch center, they interact with the central load dispatch center, and each and every state gives their own schedule, and that schedule is of generation as well as of the load. So they decide based on that how much generation is there, how much load is there. Its schedule is prepared 24 hours in advance, and obviously then 3 hours ahead. Then there is 30 minutes ahead also. And I told you the generation and the load, whatever you commit, that may change, because if you take about a particular load, because load is also unpredictable. I commit a particular load for a day for Chandigarh. It may change depending upon the changes in the season also. You will suddenly see a dip in temperature. There will be more consumption. Similarly, in summer you will find that more and more of the ACs are being used. So in that case, if you have committed 30 megawatt of consumption for a particular day and you are using 32 megawatt, for additional 2 megawatt, you will have to pay additional. And you will be allowed to draw 2 megawatt extra as long as it is not a threat to the grid. Fine. So this is how,
As long as the frequency remains within the...
Yes, the band has now been fixed between 49.7 to 50.2. So that is not allowed. And you will note that for every 0.02 hertz, the charges will keep on changing. Okay. So it is being maintained by the transmission system operator.
SLDC is having any smart arrangement for this? No, they are
No.
doing it.
No, not manually now. Yes, yes, it has been modernized nowadays, and if you see in states also, now there are they keeps on tracking data of various feeders, generation sources which would fall under their category in most of the states, and they're communicating it through directly to SLDCs. Otherwise, it becomes very difficult if you start communicating through telephone. So that becomes very difficult. And even if you see the Northern Region Load Dispatch Center website, you will find that frequency variation quite frequently, and UI charge is also given side by side.
So there's just one more point. So when a state is demanding, is requiring extra load than they are already prescribed or they are asked for, so they would be demanding both active and reactive load as well.
See, as far as active and reactive power, you cannot predict. Active demand you can predict.
What I was trying to ask you, sir, because this frequency, whenever there is a difference in the active power requirement, frequency varies, but voltage also varies whenever.
Obviously.
So shouldn't this UI rate should also consider if because of that extra demand that a particular state is asking, there should be a voltage limit also, that the voltage limit should not go beyond a particular range.
Obviously. See, these factors are considered. Voltage limit is already there. It is see, whenever the voltage limit will not go beyond certain limit if you have sufficient capacity over there. Right? And but particularly if you see a particular load center in when we have a distribution system, so they are designed in such a way that you get sufficient voltage even if you supply full. Extra demand doesn't mean that you are overburdening the system. Let us suppose if you are having a few areas where you are generating, consuming some power, and maybe few area which you feel that this will not be used right now, but they still start using it. If they start using it, so obviously there is some distribution network available for them. So it is obviously there are congestion charges also. So you need to see that if you are overdrawing, and it also lead to congestion. So other than these charges, you also need to pay congestion charges.
So in that voltage.
Yes. So it's a one concept that I am telling you. So there are a number of mechanisms, and they are being communicated, continuously to the state load dispatch centers. So so there are many control mechanisms in place which ensures the grid stability. And the biggest because I have carried out some study on this the blackout. The problem during blackout was not this frequency. You must be surprised that frequency was only 49.5 at the time when the grid collapsed. It was because of the failure of the protective devices. Fine. Yes. So they were not working properly, and that was the biggest reason of the failures. Frequency is not the only factor for this. So let's talk about the advantages of distributed generation. So in advantages, if you see from the operational point of view, it reduces the power losses in the network by supplying local demand. So I told you that if you have generation sources at the demand center, obviously you need not to supply from the transmission lines. It reduces the network losses. So that is the biggest advantage with this. It improves the voltage profile. So obviously if there is no voltage drop, the voltage at the load end will be quite high. And the peak load saving. So if you have a storage option available, so you can use it during the peak load hours, and load management programs also. So in electricity market nowadays, people independent power producers are there, their load centers, each and everyone is participating, and you need to bid. You need to bid for the generation, even for the load change also. So in that case, we can very easily manage the load, and we can also cut down generation as and when needed. And these DG sources, they will be available as and when needed. Okay, and they are generally used in combination rather than using independently because of their varying nature. So it also helps in system continuity, reliability, especially in case of the end users. So obviously where there is no power available in certain areas, if you have these resources, at least you can manage few of your demands. Then standby, you can always see in most of the organizations where we need power, like in hospitals, we already have through this. Then this capacity, it varies from micro to large, and it can be connected to distribution and transmission network. This is the advantage with this, that you can connect it anywhere, okay, depending upon that, and we do not need that transmission infrastructure for that purpose. Transmission capacity release, the congestion part that I was discussing, that obviously if we have that near to the load center, so we have the power which was earlier supplied from the conventional generator, now it is supplied by locally, so we have sufficient transmission capacity for that purpose. And with regard to the environment also, so if they are clean in nature, so the reduction from thermal sources will go down, so it will also reduce your emission. So with emission, now emission quota is coming up, so in that case you will find that it will be a huge revenue source. If you see the economic point of view, it deferred the investment in upgrade of facilities such as building a new transmission and distribution network lines. I told you that if we supply it locally, so you need not to supply use new transmission and distribution networks. It can be assembled and installed easily due to modular design. It's a small design, they can easily be transported. We do not need big machineries, like if you have to set up a thermal station or a hydro station, huge roads, huge infrastructure is needed for that purpose, so that is not an issue. It can be easily installed anywhere. Very small area is needed for that purpose. Okay. Effect on, obviously, if we have these resources, it will reduce the energy cost also, because there is no operational cost. Obviously, the only thing that they are looking for is the payback the period, and in case they are able to cover up their own capital cost, then we will be in a position to have cheaper energy prices, and they can be installed in small installments. So as and when needed, they can be expanded. Otherwise, if we plan for a hydro station or a thermal station, we need to look for that it should be able to supply certain need. We cannot have 10 megawatt of thermal station. But we can definitely have a 10 megawatt of distributed generation. So that is the advantage with this. Then obviously it's a reduced maintenance cost of digital technology. So technology is improving nowadays. So obviously this will also reduce your operational maintenance cost. The enhanced productivity, the fuel cost will go down. So obviously efficiency will also improve. Reduce reserve requirement and its associated cost. So we do not need because it is being locally met. So obviously it is scattered nowadays. So rather than keeping one unit reserve for each and every area or for a whole large area, it's being managed by locally. And even concept of local electricity market has also come up in few countries, in particular in England. There are local electricity market. In India right now we have these electricity companies in each and every state, which were electricity board earlier, but they are managing, they are communicating with dispatch center. But in countries like England, they have local electricity market, and in local electricity market, educational institution like yours or university, they can be a player in that. I can have my own resources of maybe the solar, if you see the Chandigarh solar, maybe a fuel cell or anything else, if I can have, and I can communicate with the Chandigarh electricity board department. So in that case, I can tell them, okay, I'm supplying at this particular moment, I am withdrawing. So it's not like we have right now, it's networking system, but it is a two-way communication. As and when needed, you can supply. So there are you can have independent, there can be public-private partnerships also. So there are different business models which are coming up. So in that case, reserve is not needed. So they are mostly, it is being fed by met by their own resources only. So operating cost will go down. The security of the critical load will go up. Certainly, if there is a generation outage of a hydro, maybe thermal generator, do not have supply, but now you have something in for backup for that purpose. Okay. Increase of lifetime of transformer will also go up, because obviously if because a particular transformer is managing the load for all the area, it was earlier exposed for overloading and underloading, but if it is being managed, so obviously that capacity is released, so it is not exposed to that kind of situations quite frequently, and it will increase your lifetime of your transformer. Now if you see the technological status, the electricity market has grown up. I told you that technology has increased, and because of technical intervention, the cost of generation, it is going down. And if you see, there are some new sectors which if you this the generation plant versus the cost curve. Earlier the thermal plants, you can see for 50 megawatt generation in the 30, it was quite high in dollar megawatts. Then the cost of with technology, it went down in 1950. In 70s it was further reduced, and in 80s it comes down to very large for even for 1000 megawatt. You can see on x-axis the megawatt capacity. So for 1000 megawatt capacity, the cost you can see 1980, and if you see the 50 megawatt generation in 1930. So the generation for 50 megawatt at 30 was very high as compared to the 1000 megawatt that we're generating at 1980, and it is very less. Now it has been shifted towards this combined cycle gas turbines, which is further very less. So low generating resources like distributed generation sources, they are being provided at the cheap cost. Obviously, if you see the thermal plants, no doubt with the 1000 megawatt, the cost is quite less. But the problem with that is because they are not clean in nature. We cannot depend upon them. They are depend. There is cost.
Hello.
Hello.
Sorry to interrupt you, sir. I am from Modi University. Sir, whether these renewable sources increases the reliability of the system also, because these are the unreliable sources, so reliability of the system also improves by incorporating these sources or not?
See, the question is yes or no, both. No, no, in the sense that if you see particularly that they are unpredictable in nature. Obviously, the unpredictability is a big challenge, and if we are using them in isolation in particular area, so that is not reliable. And when if you need it and the wind is not available, or maybe the solar sun is not clear, so you will not get power. But if you use it as a microgrid, or maybe in combination with storage options like we have inverters at our home, we now there are solar inverters available now. You can charge it through the solar, store it, and as and when you need it, you can use it. So they enhance reliability in the sense that if you have the storage provision, and if you are using it in isolation, then they are not reliable.
Oh, thank
Yeah.
you, sir.
So generally, the concept of microgrid that we will be discussing tomorrow. There also the concept was that rather than using them in isolation, we should use them in combination, and they should be controlled way. There should be single control which manage each and every one as and when they need to be used. That's why we can ensure their increased reliability. Now, if you see this efficiency of different technologies with the unit size, so we can see this the coal, then the nuclear is the having a lesser efficiency. Then the coal is also slightly more than that. Then gases is slightly better. Fuel cell is having much better. The advanced coal. See, in India, you must be knowing that we are having the second largest coal reserve, but we are not in a position to process it. So because of that, the efficiency of the power, the coal that is very less at present. But if you see the advanced coal, the efficiency is quite high. So that need to be worked out, and maybe because advanced coal will also lead to the lesser emission also. So based on these technologies, their the unit size and their efficiencies, we can decide that which technology to be used for what purpose. But the coal in India should definitely be used in the sense that we have a huge reserve and we need to process it. And if we are able to process it, I think our need can be easily met. And in addition to that, the focus should also be towards the renewable sources and distributed generation also, because environmental challenge, environmental concern is also there. Now the applications, if you see, they're being used particularly in electricity market nowadays, and currently they are being used by some customers to provide some and all of their electricity needs. I told you that we are having this option available that if we start generating our own power from renewable resources, I can meet my own demand, or I can also supply it to the grid. So there are different applications of DG technologies. Like for example, DGs are they used to reduce the charges imposed by the electricity utility, while other use it to provide primary power or reduce environmental emissions. See, particularly in organizations, like if you have a commercial organization or maybe a small industrial organization where the charges are slightly higher than the domestic charges. So in case you are able to meet that some part of your power, so obviously you are going to reduce that cost also. And with the passage of time, see, the time will come when there will be charges based on the demand also. Right now we are having a flat charges, whether it's your peak hour or off peak hour, you are charged the same rate. But with the passage of time, when the demand of energy will grow, the time will come that you need to pay more when the demand is more. So if you are able to have your own DGs, so obviously the charges that you will be you have to pay that time can be met by you yourself. So the DG can also be used by electric utilities to enhance their distribution systems. Many of other applications for DGs solution exist. So there are few options available like continuous power. In DGs, you can have the continuous power. I told you that when we talk about the reliability part, so in if we can have the options for the storage, so we can have the continuous power. So the maintenance cost is quite low in that case. The emission is also low, and I told you already the commercial sectors is industrial sectors are the biggest beneficiaries from this. Then combined heat and power. This in few organizations, the cooling, heating, and the power or the cogeneration is being used. They preferred. Like in thermal, if we are able to generate, we are creating steam, and the heat produced, because we need to cool down that water again, so that heat is extracted. It is used for the to meet some of the thermal needs, particularly in organization like hospitals. We need to keep them warm for the purpose of the patients. So combined heat power is another factor which benefit that we get out of this. So here we again it will lead to the overall higher efficiency, because if you see the combined efficiency from the heat and the power, it will be high, because part of this is also being for the heating purpose. Then the peak power, you can see in peaking the power application, these is operated between 200 to 300 hours per year to reduce the overall electricity cost. The peaking applications are only operated a few hundred hours per year, and peaking applications are being used to generate electricity wherever utility has the peak rates. So particularly in Western electricity market or European electricity market, there are different rates at different times. So their DGs are being used, and there are private players which come up and they are ready to supply, and there is a competition between them. So you can negotiate with any power producers, and you can have a bilateral agreement with them, and they will supply for you during the peak hours. So that may be at lesser rate as compared to which you need to pay to the normal utility. So this is another benefit that we get from this. So the important DG characteristics for the peaking power includes is that it has the cost is quite less. The second important part in this is the quick startup time. See, when during peak hours, you should be able to start it fast. If you see the thermal generator, in thermal we need at least 2 hours time to heat it up so that it is in a position to generate a steam and then start using generation. But the sources like the battery storage, etc., they can start very quickly, and as and when you need, they can supply it. And the peaking power application can also be offered to energy companies, to the clients who want to reduce the cost of buying electricity during the high peak periods. And DG peak units are being used mostly in commercial sectors, and the most common application of educational they are in educational institution, then retail sites and industrial facilities. The green power, so because they have lesser emission, they have very efficiency, though it's not quite good, but still better, and the lower operational and maintenance costs. So these are the advantages being provided. So it is able to provide green power, and particularly when this emission quota will come into picture, then you will have a fixed amount of quota for the power generation. And if you see in India, the emission will be allocated like this, that a particular country will get a fixed amount of emission. That emission will be further divided for few to the power generation sector, few for the other applications. And if you see the power sector, if you need to meet the growing demand also, then it will not be possible for the thermal sources. So in that case, it will be mandatory for us to move towards these resources. And we may also need to buy the emission quota from the other countries. Like we are still working with Bhutan and Nepal. We are working on the hydropower sources. So in that case, we need to we use more of these sources. Then another important factor or the benefit that we get from the DGs is the premium power. The premium power we categorize into three different categories. One is the emergency power system, the standby power system, and the third is your true premium power system. So emergency power system is, which is needed by few customers, like which are staying in apartments, offices, commercial buildings, schools. So if they have an independent system which them provide them electricity automatically when they need during that time. Let us suppose if there is a cut in a particular area and you need it for educational institution, so you can get it from your on source. Similarly, the standby is very important. We discussed already also. So there in areas like airports, then your hospitals, police stations, military bases, where we need power at at different intervals, or we cannot compromise on that. So you need to you can use it as a standby power system. Then there is some true power system, premium power system. The premium power system means where the clients is liable to get the power uninterrupted, and this is free for all the power quality problem. Such a frequency, there is no frequency variation, the voltage is sufficient, there is no transient, no dip, no surge, and the rates for that will also be different. So the different type of customers are there, and DGs can ensure that you choose your customer, you can have a bilateral negotiation with them, and ultimately you can supply customer, and you will also be getting rates as per your power you are supplying and the quality of the power you are supplying. That I told you that this is another important benefit that we get, the transmission and distribution deferral, that we do not need to install the distribution and the transmission network for that. They can be installed anywhere at any location at any existing system, and that will reduce the cost of your additional transmission distribution network. So here the cost of installation is less, the dispatchability is easier, okay, and the losses are also reduced. The ancillary services are those services which are provided during the emergency conditions, like we have the reserve, we have the black start in case there is a blackout, then how to restart it, and reserve is another important factor. Even reactive power is also being supplied by the DGs, so that is the biggest advantage that we get in terms of the ancillary services from the DGs. Then we have the option for remote power, that with the remote power application, distributed generation is used to provide electricity to a facility that is isolated from the grid, that we can use in those areas where it is easily available, or we can form a small microgrid over there. DG unit, in those cases, if it is a sole source of power for facilities, so partial load can be met by the DGs. And the characteristics of the DGs in those remote power applications, they should have higher efficiency, it should be dependable, it should be able to measure technologies with the storage, and it should have the lower variable maintenance cost as well. If we, there are some applications and types of the important characteristics. There are few characteristics which are very important, there are few characteristics which are moderately important, and they are relatively unimportant. If you see the continuous power, then for continuous power we should have high efficiency, and we should have variable maintenance also high, and then dependability is also important characteristics. If you see the combined heat power, in that case the important characteristics is high efficiency, the variable maintenance, and dispatchability and dependability also. For peaking, the peak load that we are saying, in that case the low cost is important, then the fixed maintenance is also important, and dispatchability, that how fast you can dispatch it, that is, these are the characteristics which are important for the DGs. Then if you see the green, in green the emission is important in the case, whereas efficiency and thermal output, they are moderately important. For emergency services, the low cost is very important, the startup time, and that is very, very important, the fixed maintenance is also important, and dispatchability and dependability are very important characteristics for this type of applications. For standby application, the low cost is very, very important, then the fixed maintenance, dispatchability and dependability is also very important. Similarly, if you talk about the reserve, in the reserve startup time is very, very important, it should be able to supply immediately. Similarly, it should be able to dispatch very fast, so, and it should be dependent also. For reactive power, again, this dispatch is very important. For controlling the voltage, the important characteristics is this dispatch and dependability. And if you see the local area security, the low cost is important in there, fixed maintenance is important, and dispatchability is important. So these are various applications, and we are having some characteristics which, on the basis of which we can decide which are the characteristics which are important for the current applications. So this is what is the table given, and we can see that which are the characteristics are important for a particular applications from the DGs. If you see the cost of the DGs, the characteristics, if you see the size, in internal combustion engine, it is up to 5 to 50,000 kilowatt. Then wind turbines, they are small and large. They are from few kilowatts to maybe a megawatt now. The micro turbines are obviously of low kilowatt range. The fuel cell is also of not very high capacity, but still research is going on. Solar cell is also of few kilowatts because it needs a huge space for that purpose, and it's difficult to transport if we generate we manufacture a very large capacity solar panel. Then if you see the installation cost of the combustion engine is comparatively less as compared to the other technologies. Solar is still very costly in that matters. And if you see the per kilowatt hour cost of the solar, the electricity cost, the cost of per kilowatt hour is least in case of the wind. Obviously, it doesn't need in that matter. If you see whether they are commercially available or not, so we do have whether it's internal combustion engine, wind turbine, micro turbines, fuel cell. Fuel cell, obviously there is no research is going in each and every area, but still fuel cell is there is a lots of scope, particularly where there are lots of polymer cell being developed. There nanotechnology is being used for enhancing just efficiency of fuel cell, even storage also. Similarly, solar cells are also available, but still here also there is lots of development going on. The efficiency part, in efficiency, still it needs to be improved, and we can see the internal combustion engine having the efficiency of 45%, of micro turbines 25 to 30%, and fuel cell up to 40%. This is some of the applications, and we see the different type of technologies. If you see the continuous power, internal combustion engine can be used for that purpose. Micro turbines and fuel cell can be used. For combined heat and power, internal combustion can be used. Micro turbine can also be used. Fuel cell can also be used. For peak load, internal combustion, micro turbines, because wind and solar are not predictable in nature, so they are not used for they are not kept for the peak hour. For green, obviously wind turbines and solar are preferred. For emergency services, internal combustions are used. Standby, obviously internal combustion is preferred because others are not reliable. Obviously fuel cell can be used in that matter. For premium power, micro turbines and fuel cell, they supply good power of proper quality. Spinning reserve is supplied from the micro turbines because they are based on gas, and you are in a position to supply that gas and generate power for spinning reserve purpose. Reactive power can be supplied by internal combustion engine as well as by the micro turbines. Voltage can also be controlled by this. And if you see the remote power can be supplied by almost by all these technologies. Now there are a few challenges in the scope. The scope is that obviously power quality is a challenge with this. The cost of operation and maintenance is a challenge. The long-term reliability of these units also need to be seen. Interconnection, where to connect, the grid code also need to be ensured. But there is scope also. That is a huge the market coming up. That the time will come that when you will be able to purchase power from your DGs of your choice, which provide you can have a bilateral agreement with them. There are favorable policies being framed by government, so there is a huge scope for the private players, for investors to invest in a distributed generation, and there is lots of technological developments going on nowadays. And with technical intervention, we hope that this distributed generation, the development will take place quite rapidly in years to come. So I hope I should conclude my lecture over here. I hope I'm able to meet some of your expectations, and if you have any doubt, please, you are free to ask me questions now.
Hello.
Yeah.
Sir, this is Pramod Bhatt from Modi University.
Yeah.
Sir, our entire power generation, transmission, and distribution system is designed for unidirectional power flow.
Yeah.
When we include these non-conventional sources, renewable sources, then various type of disturbances occurs like voltage regulation, harmonics, etc.
Yeah.
So is it good or better to include these sources in the existing Indian perspective rather than, or it is a myth just which is possible in a smart grid like themes where everything where the corrective action would be taken automatically, like, because what happens, reverse power flow or harmonics, unnecessary inadvertent tripping of the protection system also occurs. So is it possible or good to include in the present existing Indian scenario, like?
See, as far as directional power flow is concerned, that is always there, but we do not have options. We need to go for the renewable resources, and I hope with the technological development, we will be in a position to control all these phenomena, and the power quality will not be a challenge. And as far as the sources like wind and solar are concerned, mostly they are located in remote areas, and most of them are used to feed the local demand only. And even if they are connected to the grid, then it is ensured that they supply power of the required quality. So that will not be a challenge. I think with the passage of time, with development in technology, this will be done automatically. That will not be a problem. Yes, at present we still need to work.
Any other
Thank you.
center?
Thank you.
Anyone else from Modi University want to ask a question?
No, madam. Thank you, madam.
Thank you. Any other centers?
Yes,
Rajasthan
ma'am.
Technical University?
Ma'am, this is Vipul Agrawal from MIT.
Yes.
Yeah.
Ma'am, I have a question that what will be the effect of increased penetration of the distributed generation resources into the distributed system?
Into the distribution system. See, we
Yeah.
already discussed about that in distribution system, obviously the biggest advantage that we will be getting out of this will be that it will improve the voltage profile. That is the important factor. It will reduce the losses also, in the sense that we do not need to supply power from the main generating resources, and we can meet it locally. So this is how it is going to improve the system.
So actually, if the generation increases beyond a certain limit, then what we can expect that it is a challenge for the power system stability or not?
See, as far as beyond the limit, I think that is not uh, a, a point that we should say. In the
Ji.
sense that there is a mechanism in place. You are having uh, control mechanism in place, that how much generation you want. You are obviously, if you see thermal, you see wind, or you can see the hydropower. We ensure that how much power is to be delivered. We are supplying input according to that only. So generation cannot increase. In case there is increase in generation, let us suppose if load goes down of a whole system, then in that case also there is a provision that we can disconnect the generator immediately, so that it is not going to cause any problem for the frequency of the system.
So it means the transient stability analysis can be done on the distribution side.
No, 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 no. No, in distribution side, if there is, we need to focus it on the generation side particularly, because transient, if you see the term, the transient that we have is for a large change. So the large outage of a generator or a transmission line, then this is what is the transient stability. Stability, whether it is a small, we say it's small signal and large signal. When we say that the generator end, it is particularly the generator end, or the large signal stability, and the small signal stability can be discussed in the distribution areas.
Okay, sir. Thank you, sir.
Hello,
Hello.
hello. I am from IEC Greater Noida.
Yeah.
Okay. Okay.
Sir, in the slide of challenges for distribution generation, my question is why voltage regulation problem occur in distributed system and how it will be minimized. Actually, what is the voltage regulation problem in practical sense
Okay.
for
See,
generated system?
see the voltage regulation problem that that is there in the power quality. I told you that over voltage. If you see that this slide, if you see read this, that if the downstream DG output exceeds the downstream feeder load, there is an increase in the feeder voltage with increasing distance. And if the substation end voltage is held at near the maximum allowable value, the voltage downstream on the feeder can exceed the acceptable range. So generally, particularly in distributed generation, which is connected at the distribution end, there can be this kind of problem. Then only there the voltage regulation problem can occur.
So,
Though
sir, small voltage regulation value is more preferable than high value.
oh, see, we should have zero voltage regulation. Zero voltage regulation means the better voltage regulation.
Okay, sir. Another question. Another question, sir.
Hello.
Hello, yeah.
Sir, I have a question. I'm from IEC.
Okay.
Sir, how to synchronize a solar power plant connected to a distributed system up to 30 volt 50 hertz?
How to connect? Pardon?
Sir, how to synchronize a solar power plant connected to a grid, which may be a distribution system up to 30 volt 50 hertz?
30 volt, 50 to 30 volt.
30 to 30 volt 50 hertz.
See, we do have the hardware in place. We can directly connect the power generated from a source, which can be connected to the grid directly.
Sir, is there any necessary conditions that two systems must have 50 hertz and
Yes. See, that has to be there. That has to be there because see, it is not like in case of your thermal generators where you go for the synchronization that is because there the frequency it is being the voltage that is generated, it is dependent upon the speed that you are ensuring that once it moves at a particular speed it has a particular voltage level, and then you synchronize it with the grid. But as far as this is concerned, that solar panel is concerned, you can ensure that the particular voltage level is generated and particular frequency is generated. There you are having inverters for that purpose, right? So you can connect it to the grid straight away.
Another question. Hello.
Yeah.
Sir, my question is, can we add a power compensator in a three-phase generator to increase power factor?
You want to connect a power compensator.
I'm again repeating my question. Can we add a power compensator in a three-phase generator to increase power factor?
To increase the power factor. See, power factor of generator is not that important as it is for the load. So I don't know, when you say the power factor improvement, it should be of the load in particular. Why do you want to connect a power compensator to a generator? You need to improve the power factor of the load. You connect it near to the load station.
Yes, sir.
Right. In particularly in induction generators, we do use capacitor for that purpose. That is for starting purpose. So, but for improving power factor in generator end, it's not that important because you are ultimately supplying load to the power to the load. So, load power factor is important as for delivery of the power is concerned.
One more question, sir.
Hello, sir. Good morning. I am from IC College of Engineering, Greater Noida.
Yeah.
Hello.
Yeah. Please go ahead.
My question is that if I have a small distributed generation system and we have surplus energy, and I want to connect a small grid, local grid, then what should be the criteria? What should be the different procedure toward the government level? It means what should be the paperwork so that we can got permit from the government to connect our system to the grid.
See, as far as this is concerned, obviously you need to get in contact. It should be first of all a policy in your local area. Like I talked about the Chandigarh. In Chandigarh, we have a net metering system. So, if I have some solar panel at my home, I am able to generate some power. I am ready to supply it to the grid, but I cannot connect it grid directly. There will be I have to approach the local department. Where they will ensure that they will come for quality check, and once they are sure about that, only then it can be connected. The same is the case with you also. So in case you have that option, you cannot connect it directly. Yes, you can feed it to your home, maybe your neighbor, whosoever ready to take power from you. But as far as the connection to the main feeder is concerned, you cannot directly connect it unless you take permission from them, and they will give you the permission only if they ensure that the power that you are supplying is of required quality.
Okay, sir. Thank you. One more question. One more question.
Yes.
Hello, sir.
Yeah, yes.
Sir, my question is regarding the DG placement.
Yeah.
Sir, what are the factors to decide the location of DG placement in a bus system, distributed bus system?
See, when we decide the main criteria, that is basically we use sensitivity analysis for that purpose. In sensitivity analysis, like we can think of the voltage. One of the criteria that is considered, that in case the voltage is less in certain part of the areas, you can fix that particular bus where you can connect your DGs.
Okay,
And the second important part and the cost. Cost is also one of the, but main technical factor is your the voltage profile that we have.
To attain the minimum voltage regulation.
Yes, obviously. If you see many of the papers, you will find that they use sensitivity analysis. They calculate the basic load flow, and then on load flow they find out the voltage at particular location. Where the voltage is less, the best location is considered for DG the minimum voltage level.
Okay, sir. Thank you, sir.
Hello.
Hello. Yeah.
Good morning, sir.
Yeah.
And I have challenges of DG.
Which sender you are from?
PVP Siddharth.
PVP Siddharth. Okay.
In the challenges of DC, however, this market is less predictive of load patterns.
Can you repeat your question?
Repeat the question again, please.
In the challenges of DG.
Challenges of DG, yeah.
However, this market is less predictive of load patterns.
Less predictable of low patterns. Challenges of DG. Less predictable load patterns.
Less predictable load patterns. I discussed it in detail. That load is not predictable in nature. We do have certain factors which we decide. Let us suppose we decide the geographical regions. We see the climate conditions, the seasons, whether it's summer or it's winter. On the basis of that, we decide the load. And the previous year's patterns, they are taken into account, and then we can use any forecasting technique for that purpose, and we decide that okay, this will be the load tomorrow. But that cannot be suddenly if there is a shower at night, the temperature dips. Obviously, more of the heater may be used, so the load can change drastically. Similarly, in summers also. So the load is not predictable in the sense. The second important part that I told you is that there are different type of consumers. The consumers, the commercial, residential, industrial, so they have different priorities. So that is why it is, we cannot say it's very much predictable.
But we can estimate the load, right? From the previous data that we can estimate load, but we cannot.
You can estimate. See, I told you there are number of techniques available for prediction, but you cannot say that they are exactly the same, which ensures that okay, this much is the load available that will be available tomorrow, and you need to spend that much only. You will always see the variation in that.
Okay, thank you.
More questions from any other centers? Okay, now we can break for tea. It's almost time is for the next session. So have tea fast and come within 10 minutes. We will reassemble by 11:55. Okay, and Dr. Poonam Syal will be taking the next lecture. Thank you so much. Thank you, Dr. Verma.
Okay, thank you.
Sir. So can I have this?
You can just copy it.
Sir, chai ke liye le jao, please. Let me. He was telling he's a student of yours. To copy. Chai le lijiye, sir, please. I'm coming, sir. Yes, sir. He is Okay, welcome to all participants at the different centers. I am happy to introduce Dr. Poonam Syal. She is a colleague of mine working in our department. She is a PhD from Punjab University, MTech and BTech from Punjab Engineering College, Chandigarh. And she has been working in this institute for the past 30 years. Her main area of work is renewable energy sources and mainly on solar, PV and thermal. So she will be engaging this session on solar energy sources, PV and thermal both the technologies she will be handling. Over to Poonam.
Okay, thank you, ma'am. So good afternoon, everyone who are at the each nodal center and at main center who are attending this short-term course. And I'm going to talk about the solar energy based technologies today. You see, one of the most important issue which has come up today is regarding the usage of energy, and because the and the focus is on using the renewable energy sources, since we know that the fossil fuels they are creating a lot of greenhouse gas emission, and another thing is that they are limited in nature. So that is why the focus is on using the inexhaustible and naturally replenishable renewable energy sources such as wind, energy from the sun, small and micro hydropower, biomass, energy from the ocean, etc. As you can see from this slide, this shows the potential of various commercially exploited energy sources in our country, with having a large potential of more than say 10,000, more than 1 lakh megawatt, like in the case of wind energy and solar energy, and the installed capacity as per the reflected by the Ministry of New and Renewable Energy Sources, who is the key ministry for promoting the renewable energy sources in our country, is that still lot of work needs to be done in these areas. Like in the wind energy, still around 21% of energy has been harnessed so far. In solar energy, just around 3%. In small hydro, we have exploited around 20% of the energy which is available today. And in biomass, it is around 11% or so. And you might all be knowing that the most important resource of renewable energy is sun. You see, if we can harness this energy from the sun for a minute, it can serve the demand of energy in the whole world for 1 year. So that is the potential of the solar energy on our earth. But when we see the usage in our country, we have exploited around 13% of the total renewable energy sources under various category, and we have exploited the solar energy to the least. And this slide shows that we have a lot of potential to use the solar energy in our country, as you are all knowing, like in the state of Gujarat, Rajasthan, Madhya Pradesh, Maharashtra, Andhra Pradesh, we have a lot of potential of exploiting the solar energy. Like in the Rajasthan, we have more than 700 units of energy which has been installed, and in Gujarat, it is we have installed more than 900 megawatts of solar energy in our country. To say a few about this thing. Then, as we all know, that sun is basically a sphere of high temperature gases, and it is having a high temperature as well as high atmospheric pressure, due to which it creates a conducive environment for fusion reaction to take place. What happens is that in the sun we have hydrogen atoms which combine to form the helium atom, and thereby releasing the energy, which is as you know, it is because of the Einstein equation, that is E is equal to mc square, where delta m is the change in the mass. So when the hydrogen ion combines and they are combined into the helium atoms, there is a change in the mass. That is, the mass of the helium is lesser than the individual hydrogen atoms which are combined, and thereby the difference of the mass is converted into energy, and which reaches on the surface of the earth in the form of electromagnetic radiation. This radiation, that is the speed of light which expands outwards from the sun, is at the rate of 1,86,000 miles per second. And it takes generally around 8 minutes for the radiation to reach to the surface of the earth from the sun. So this slide shows the wavelength spectrum of the solar energy radiation, which generally falls into the ultraviolet region, visible light, and infrared region. As you see that the UV light's wavelengths, they vary from 0.01 to 0.4 micrometer, while the visible light and infrared, the wavelengths ranges up to 1.5 micrometer from 0.7 micrometer. And we receive mainly the sunlight in the form of visible light, that is 44%, infrared, that is 48%, and some amount in the form of ultraviolet radiation, that is 7%. So as the shorter the wavelength, the greater is the energy level associated with it. So whenever we talk about the solar solar energy utilization, the main focus is the amount of energy which we receive from the sun at a particular location, and this is known as insolation. It is the sum of direct radiation, solar radiation, which is received on the surface of the earth, and also the solar radiation which we receive on the earth in the form of diffuse radiation. If the sun is directly overhead and the sky is clear, the radiation on the horizontal surface is around 1000 watts per square meter. The direct radiation is when we receive the amount of radiation which we receive on the surface of the earth without any reflection or absorption or scattering, that is without the change of direction. And while the diffuse radiation is the radiation which we receive on the surface of the earth when it is absorbed by the air molecules, by the clouds, or reflected by it, or scattered by it, or the dust particles, or the ozone layer. So that energy is known as the solar insolation in the form of diffused radiation. And the shadow which is formed on the surface of the earth, that is because of the direct radiation. Around 19% of the solar energy is absorbed by the vapor, ozone, and dust before reaching on the surface of the earth. 8% of the energy is dispersed in the atmosphere because of the various dust particles and other clouds, etc. And 17% of the energy is reflected by the clouds, and around 4% of the energy is also absorbed by the clouds, and 6% of the solar energy is reflected by the Earth's surface, and around 46% of the energy from the sun which is received on the surface of the Earth. On an average, we receive around 4.5 to 7 kilowatt-hour per meter square of the solar energy in India per today. And total solar energy which is reaching India is of the order of 60 into 10 raised to power 13 kilowatt-hour per year, and it is also equivalent to 20 times world's total coal reserves. The huge potential of the solar energy can be seen here, that if the solar power plants are installed on 1% of the world's desert area, it would generate the world's entire electricity demand today. Now we capture the solar energy to meet our energy demand, and this energy can be harnessed in two ways. One is solar thermal, that is the heat of the sun. Another is the photons present in the sun, that is light energy of the sun through the photovoltaic effect. Now as we can see, there are various applications when we capture the heat energy of the sun. We can use it for heating the water. We can use it for cooking our meals. We can use it for drying the agricultural produce or for other commercial activities used for drying in different industries. And we can also use it for producing the distilled water. And some of the application with regard to photovoltaic usage of photovoltaic usage of the solar energy is using the photons of the sun to get the DC electricity by having a semiconductor material, mainly silicon, known as solar cell. We can use it as a solar PV lantern or solar PV pump for pumping the water, and also we can harness it for generating the electrical energy. So as the name implies, the solar thermal describes the technologies that use the heat of the sun for heating purpose or for producing the electric power. The heart of the solar thermal application is the flat plate collector. It basically consists of an absorber, which is flat plate and which intercepts and absorbs the solar energy. It has a transparent covers that allows the sun energy to pass through it, but it reduces the heat losses from the absorber. The transparent covers are mainly made up of the toughened glass, and they act as just like when we trap the greenhouse, that is our gases like carbon dioxide, which traps the heat in the environment on the surface of our earth, like greenhouse effect. Then we have a heat transport fluid, mainly water or air, which flows through the tubes, and thereby it extracts the heat from the absorber, and it can be used to meet our energy demand. And then this system is insulated with the rock wool or mineral wool, so that the heat is retained inside, and we can maximally get the output from the thermal energy which is absorbed by our thermal system. Now this shows the diagram of the cross-sectional diagram of the flat plate collector. The various components are, we have a toughened glass, which there are BIS standards for the various solar appliances, and similarly it is available for our flat plate collector, which is used for the solar water heating system. It has a toughened glass with the 4 mm thickness. It has also it is encased in the aluminum box. It has absorber fins, and it has a rock wool insulation used, which is 50 mm. And then there are riser tube which are 1/2 inch in diameter, and the header tubes are there for the inlet of the water and outlet of the water, and the diameter of these pipes is 1 inch, and they are made up of copper, which is having good thermal conductivity. Now the flat plate collector, the specifications of this is as IS 12933 in our Bureau of Indian Standards. These flat plate collectors, they transfer the heat of the sun to the water either directly or through the use of another fluid and a heat exchanger, depending upon the quality of water. Now the absorber plates, they transfer the energy from the solar radiation to the fluid that circulates within it, and they're often coated with the black chrome to maximize the amount of the radiation collected. The material used for this absorber plate is either copper or aluminum with the copper tubes, and the diameter of the header, that is the main tube which carries the water to the system, it is around 25 to 26 millimeter, and diameter of the riser tube is around 13 mm, and distance between the two risers is 120 millimeter as per the standards. Another important component of the solar flat plate collector, it is the glazing or the cover on the absorber. It is either a sheet of glass or other clear materials like plastic to trap the heat within the collector, like the function of the glass in the greenhouse. And as I have already told you, the toughened glass with thickness of 4 millimeter, that is the minimum is recommended, and so that we have a good amount of transmittance, which should be equal to or more than 82%. So as you can see in the diagram, whenever we have solar radiation, which are generally in short wavelength radiation from the sun, when they pass through the glass, then whenever they heat the glass inside, and they are transferred into the long wave radiation. But the glass has a property that it do not allow the long wave radiation to pass through it. Thereby, the heat is trapped within the enclosure of the flat plate collector. So this heat is transferred to the tubes which carries the fluid or water, and this heat can be extracted by the fluid or water, and thereby meeting our demand of getting of receiving the hot water. Another important part of the flat plate collector is insulation, so that we can prevent the heat from escaping through the back of collector and also from the side of the collector. The generally PUF type of insulation is used, and we also have a rock wool with 100 millimeter thick of 48 kilogram per cubic meter density for the same. Now, in certain cases, it is essential to use the heat exchanger in the solar water heater, especially if we don't have a water which is clear, like which is potable, or you can say which do not have hardness. If the water is hard in nature, what happens is it produces scaling in the water carrying riser tubes, and thereby what happens after a few years, the pipes get clogged, and it is very difficult to clear out the scaling from these pipes, since they are of a very less material thickness of material. It is made of the copper, and thereby the system doesn't function as desired. So it is very important that to maximize the life of our system, we have to use another fluid in our main this heating water system. That is generally the oil or ethylene glycol mixed with water is used, depending upon the temperature conditions, or even this our distilled water is also used in the main working fluid, and then the heat from this working fluid is transferred to the water. So this is generally made up of heat exchanger is generally made up of copper or stainless steel tubes, and minimum of 0.24 square meters of heat transfer area is required per 100 liter per day of capacity. And even the heat exchanger is required when in the colder region, where the temperature goes below 0 degrees Celsius, like in the hilly areas of Srinagar or Uttarakhand. Now, what happens is that due to the low temperature, the water can be converted into this ice, and then the system will not function properly. Therefore, we use ethylene glycol as the main working fluid in that for that particular areas. They are also known as antifreeze solution. As you can see in this diagram, there is a heat exchanger, but the another thing is, when we are employing the heat exchanger, we have to install the circulating pump so that the water is can be continuously flow in the system. Even the storage tank, which is a water storage tank having the hot water inside, that is around 1.5 times capacity of the solar system, and this is also thermally insulated, so that we can retain the heat which we receive from the solar energy. So as a system, if we see the solar water heater, it contains a absorber blackened copper sheet, and to the back of which are attached copper pipelines, a transparent cover, and it is placed above the absorber to reduce the heat losses. The absorber is insulated at the back and sides to reduce the heat losses. It has a storage tank, and it also has a insulated piping, which are generally made up of galvanized iron, and they are insulated with 50 millimeter of thickness of the rock wool. So solar energy heats the absorber surface, and water flowing through the tubes attached to the absorber. Cold flow of water flows from the bottom of the storage tank to the collector, and due to the absorption of the heat in the absorber plates and tubes, the riser, that is the riser tubes, the heated water rises on the top of the storage tank, and this is transferred to the insulated storage tank, either with the pump that is known as forced flow or active type of solar water heater, or without pump, which is known as thermosiphon type of solar water heater through natural convection. It is also known as passive system. So as you see, this is this diagram shows the thermosiphon solar water heater. Here you see there is a minimum height difference which is required between the bottom of the water tank and top of the collector. It should be minimum 1 feet so that the thermosiphon effect can continue, and automatically the water moves because of the density difference. That is, the hot water is having the lesser density as compared to the cold water, so it rises up and it is stored in the upper half or upper part of the water tank, while the cold water is there at the lower part of the water tank, and the continuous flow is maintained because of the minimum height difference which needs to be maintained as shown here. Another important factor is the orientation and the tilt angle. You see, we want that we should have the maximum efficiency from the solar appliances which we are using. That is why we want that the solar radiation, whatever amount is available, we should try to harness that to the maximum extent. So that is why we place all our solar appliances in such a way so that they always face the sun. Generally, the solar collector is positioned in our country facing south. And another important angle is that is the angle at which we should install our solar thermal appliances or solar photovoltaic appliances. That is the tilt angle. As you can see, tilt angle, generally for throughout the year, if you want to have the maximum output or maximum solar radiation, then it should tilt angle is equal to the latitude of the place. If we want that, we should have, since we know that due to rotation and revolution of the earth around the sun, so what happens is it's the angle at which we receive the solar radiation on the surface of the earth, it changes. So if we want to capture the sun's energy maximum in the surface in the winter season, that the tilt angle should be latitude of the place plus 15 degrees. For example, like in area like in Chandigarh, roughly the latitude is 30 degree, and when we are installing the solar water heater, they are placed at the tilt angle of 45 degrees. And if we are using some appliances which is required to be used for the maximum benefit in the summer season, then the tilt angle should be latitude of the place minus 15 degrees Celsius, 15 degrees. So these are some of the things which we need to keep into consideration when we are installing our solar thermal appliances. Orientation, it should face the sun, so that is why it should always face the this thing, orientation, south. Right. Then only thing is with the season the orientation changes, so that is not used in the appliances like solar water heater. But I am coming to the another technology, that is the another technology, that is when we use it for the cooking through solar steam concentrating system or through solar photovoltaic. Then the other tracking is also used. Now this solar water heater, one I have talked about earlier, it was regarding the flat plate collector. Another type of solar water heaters are also available, which is known as evacuated tube collectors. They are made up of borosilicate glass, and various tubes are there, as you have seen earlier. So basically it is made up of double layer borosilicate glass tubes, and which are evacuated, that is the vacuum acts as the insulation here. And the outer wall of the inner tube is coated with the selective absorbing black material for absorption of the solar radiation, and which transfers the heat to the water which flows through the inner tube. The advantage of this system is that there is no problem of scaling. Whenever the scaling is there, then it can be easily cleaned with the brush, just we put inside and clean it out. And another thing is the cost. It is having around 30% lesser expenditure as compared to flat plate systems, so it can be used safely for the hard water. Then Generally, the surface area also required is lesser as compared in the evacuated tubes type system. That is, for 100 liter per day of solar water heating system, the solar collector area required is 1.5 square meter, whereas for flat plate collector, the area required is 2 square meter. You see, as a thumb rule, generally when we want to install the solar water heater, it is estimated that 25 liter per day is sufficient for meeting the energy demand of one person. So for a family of 4 person, the capacity which is recommended is 100 liter per day. And in our institute also we have installed the flat plate collectors type of solar water heaters in our various hostels as well as PG guest house also. It has been found that a 100 liter capacity of solar water heating system, it saves around 4 to 6 units of electricity per day, and it saves 1500 units of electricity annually with 300 clear days, and it also prevents the emission of 1.5 tons of carbon dioxide per year, and the life of system is around 15 to 20 years, and the payback period is around 4 years. Another application of solar thermal conversion is solar cooking of our food. One of the appliances available for the purpose is the box type solar cooker, which can be used for baking, boiling and roasting for domestic purpose for a family of 4 to 6 persons, and it generally helps in savings around 4 to 5 cylinders in a LPG cylinders in a year. It has the inner cooking box or tray. It is made up of aluminium sheet. It is also coated with the black paint, and similarly the inner tray as well as the containers also, they are also painted black in color. And the outer box, it is made up of galvanized iron or aluminium sheet or fiber reinforced plastic. It has a double glass lid covers, and these are having a spacing of 2 centimeters between the two glasses, so that insulation is provided, and we have to prevent the heat loss from the upper side of the solar cooker. Another important part of the solar cooker is the mirror, which helps in increasing the radiation input and thereby increasing around 15 degrees Celsius temperature inside the solar cooker. So in addition to the solar radiation that are falling directly on the cooking utensils, the solar radiation which is falling on the mirror, that is also reflected towards the cooking utensils, thereby raising the temperature. Another type of solar cooker is the dish type of solar cooker. It's as you can see, it is parabolic in nature, this dish, and all the radiation which falls on it, they are focused on the receiver at the focus point. The aperture of the diameter is 1.4 meter and the focal length is 0.28 meters, and the reflector material which is used is anodized aluminium sheets, and we can achieve the temperatures up to around 400 degrees Celsius, and it can be used for frying and boiling also. It can boil 2 to 3 liters of water in half an hour. But the thing is that now this type of solar cooker, it has to be tracked with the sun, so it has to be adjusted by say around 15 to 20 minutes during the cooking time. It saves up to 10 LPG cylinders per year, and it can cook the food of 10 to 15 persons. So this shows how the solar radiation is concentrated and it is focused at the receiver point. Another system for cooking, it is known as solar steam cooking system. Here we have elliptically shaped parabolic solar concentrators. They are arranged in the parallel modules and they are known as Scheffler dishes, and they are aligned to the east-west directions. And what happens is the sunlight, it is focused on the receiver, which is placed in the focus of the dishes, and this over the receiver we have a header on which which is half filled with the cold water, and because of the heat energy received at the receiver from the sun, the water is converted into steam, which can be stored on the upper half side of the header tubes. These Schaeffler dishes, they are made up of high quality glass mirrors with the minimum reflectivity of 90%, and they have a size of 16 meters square, and there is an automatic tracking mechanism provided in this system, because after every 5 minutes it has to the position has to be changed according to the position of the sun. The working fluid pipes, they are as well as the headers or the water steam tank, they are insulated, and the temperature range of the working fluid, generally water, it is 150 degrees Celsius to 260 degrees Celsius. So whenever the steam is formed, this steam is passed to the kitchen. There are special vessels which are double lined vessels, and the steam flows on the outer this capsule, and in which the as you can see, there are pipes which are steam carrying, and then there is a cover of the vessel which contains the steam, and because of the heat, this is transferred to the food which can be cooked, and generally the cooked food is boiled, right? We cannot fry or do other type of cooking in that, only boiled, like you can prepare pulses or rice or some like tea and other things with it. It is found that 3 to 4 dishes of 16 square meter each, they are sufficient for cooking food for around 250 to 300 persons. And for in this when we install such type of system, then for it can save around 1 to 1.5 this our LPG cylinder every day when we are cooking for around 250 persons through this solar steam concentrated type of cookers. It can also be used for other purposes like boiler feed water preheating, washing in laundries, oil heating for cooking or industrial applications, and also for the milk pasteurization. Another application of solar thermal energy is solar still, that is to desalinate the impure water, which is brackish or saline water. It can be used in industries for industrial processes, hospitals or dispensaries for sterilization. It can also be used in garages and automobile workshop for radiator and battery maintenance. Here the principle, we have a shallow triangular basin which is made up of fiber reinforced plastic, and it is painted black so that we can absorb the solar heat effectively. As you know that black color, it absorbs the solar thermal energy maximum. Then the top of the basin is covered with the transparent glass, and the edges of the glass are sealed, and it is the airtight and watertight, this solar still. So this line diagram shows the working principle of the solar still. We have the solar energy which falls on the water, which is there on the base of the solar still. It is few centimeter in the level of the contaminated water is placed. So whenever the solar energy falls upon the water, and inside the basin, the temperature eventually rises up, thereby evaporating the water, contaminated water. And whenever this contaminated water which is evaporated, the water vapor, they touch the glass. Now the glass is having the lesser temperature as compared to the inside temperature of the enclosure. They are converted they are converted back into the condenses, this droplets. Now because of the slant, which is around 40 degrees of the transparent cover glazing, it flows down, and then this purified water is collected in the container. Generally, we get around 3 liters of distilled water every day per square meter of the solar still. Another application of the solar thermal energy is drying of the agricultural crops. It is generally used in food processing industries for dehydration of fruits, potatoes, onions, and other vegetables. It is also used in the dairy industries for production of milk powder, etc., for seasoning of wood and timber, and also in the textile industries for drying of textile materials. So this is a simple direct type of solar dryer. Here we have a box which is again it is having a transparent cover, and there is a wire mesh on which we place our agriculture produce, and as you can see from this diagram, the air flows from the bottom. We have the holes at the bottoms of the solar dryer and also at the top and back side of the solar dryer. So due to the heat which is generated within the solar dryer, the airflow is there, and due to the convection currents are formed because of the heat inside, and these air, it carries out the moisture from the crop which needs to be dried up, and thereby drying the crops quickly as compared to open drying, as well as hygienically also. Now another type of solar dryer is indirect type of solar dryer. Here we have air heater which is attached to the solar dryer. In this air heater, the air which flows to the flat plate collector, it gets heated up and it flows again through the chamber in which we have agriculture produce which needs to be dried, and it carries away the moisture from the agriculture produce. Now this is the having a more faster drying as compared to direct type of solar dryer, and it is very much useful for drying the cash crops. Another application of the solar energy is when we use the light, that is photons or the particles of the solar energy, to convert it into electricity. These photons, they strike the cell which is known as solar cell or photovoltaic cell, and thereby producing the DC electricity. So when we have enough sunlight which is absorbed by the material, or generally silicon type semiconductor, electrons are dislodged from the material atoms, and there is a special material, and due to which when the load is connected, then we get the power or current. So the sunlight excites the electrons in the photovoltaic material. The excited electrons are concentrated on the one side of cell, and the charge creates polarity, and connecting the positive and negative sides across the circuits, it creates the electricity. The most common PV cells, they are made from crystalline silicon wafers, and other types of materials which are used for tapping the sun energy and converting into electricity is cadmium telluride, copper, indium, gallium, diselenide, amorphous silicon. The main goals of manufacturers are to minimize the amount of materials and maximize the efficiency. And today commercially available crystalline silicon cells, they have around 15% efficiency, and the thin films, they are having efficiency of around 8%. So these shows the various type of photovoltaic materials which is being used for getting the electricity from the solar energy. There are crystalline type of silicons. They are either monocrystalline or polycrystalline. Then we have amorphous silicon, cadmium telluride, gallium arsenide, and then new technologies which are coming up are from organic, dye-sensitized, and concentrated PV. This shows that how much this is a thin film solar cells. Now these various type of photovoltaic technology materials, they have different efficiency. The best one is given by monocrystalline silicon, and the area required is also less, and the efficiency is also high as compared to other, but the cost factor is also high associated with it. That is why another type of materials are being researched, and also manufacturing process is being optimized to get the maximum efficiency and with minimum and low cost material for harnessing the energy from the sun. Now this the photovoltaic cell, generally it can vary from the size of 1 centimeter to about 10 centimeter across. And a conventional solar cell, it consists of a wafer of silicon which is around 1/50th of an inch thick. And the photovoltaic cells, like batteries, they generate the direct current which can be used for the small loads. One cell has a very small power output. It ranges from 1 to 2 watts. No, since it is not enough to provide power for most application, these cells are electrically connected into the series and parallel connection so that we can get the desired output of power, and these are connected in the form of array. It has been found that each solar cell generally generates around 0.5 volts, and 36 cells are usually soldered together in a series in the form of module with an output to charge a 12-volt battery. And the solar cell will produce around 25 to 30 milliamperes per centimeter square of current. 1 square feet of solar PV module, it gives an output of 10 to 12 peak watt. Generally, we say peak watt as the unit for this solar cell, because you see the rating of the cell of solar cell by any manufacturer is given at the ideal conditions, like we have 25 degrees Celsius temperature and so certain amount of solar energy available to get the maximum efficiency. But actually the conditions of the climate are quite different. We get lesser amount of efficiency from the solar cell. So that is why the rating is given in the form of peak watt. So this shows how they are connected like batteries to increase the voltage and power output, and assembled in the form of module or arrays to meet our energy demands. This is how they look when they are combined together to form an array.
Excuse me.
हाँ
In the
जी.
previous slide, the modules are concerned.
Hmm.
Why are these small gaps left on the module? Why aren't they covered with the solar material itself to increase the solar area? In the previous slide, when you were showing the modules,
Yeah.
so, the black part that is shown, that is basically that absorbs electrical energy. So why are these white spots? Why aren't we using a complete film to
No,
the entire module?
the production of this is in the form of cells only. So they has to be
So
practically connected
if we use,
together.
rectangular cells, in that case, we will not be wasting the white area that is left.
No, white area, it is just you can support and other things. No, that doesn't matter. The main problem is the cost of the cell. You see,
Ma'am, if you consider the entire module,
they are available in the square form also. Okay. The question is, it is not always the circular in shape. They are available in the square form also. You can see in our this thing also, there is a lab, renewable energy lab, and there you can see the multi-crystalline type of technology, and they are available in the square form also. This is just a photograph which I have captured, which I have got, which are in the circular form. Now the generally you see the standards are that the solar cells, they are characterized by 1000 watts per meter square and radiation falling on it with 25 degrees Celsius. They are standards. So for the 10 centimeter solar cell having an area of 100 centimeters square, 15% efficiency, we just get 1.5 watt peak of the power, and actual power output is always 20 to 40% less than the rated power specified, because it is dependent upon the sunlight, which varies around the day, and the climate condition, which also varies, and the temperature also varies along the day. So that is why we are not getting the rated. One of the application which has commercially exploited and is quite useful in the areas where we have a regular power cut is the solar photovoltaic lantern, where we have a module of 30 watt and lamp which is CFL here we are showing, but nowadays LED based is also solar PV lantern has come, and they require a lesser capacity of battery as indicated here. Here with CFL we require battery of 12 volts and 32 ampere hours. Another application is the solar home light. Here similarly we have lamps, and DC fan can also be, a small DC fan can also be connected to meet our energy requirement. Another application which you might have seen, and it is also installed in our institute campus, that is solar street light. It basically consists of 74 watt peak solar PV module. We have 12 volt 75 ampere hour of tubular plate battery with battery box and charge controller come inverter. You see, we get the solar energy during the day, but we use it for the night, when especially for the lighting purpose. So what happens is that during the day the light is the sunlight is captured and it is converted into DC electricity because of the usage of the semiconductor material, and it is stored in the battery. And then during the night when there is a sensor which senses that we need the light at dusk, then it automatically our CFL or LED based light, it is switched on. And during and the sensor, when it senses that light at the dawn, then it automatically switches it off. Another application in the solar PV energy is the solar PV pump. Here we use DC surface centrifugal monoblock pump set for lifting the water from the bore or open well or water reservoir for minor irrigation and drinking water purpose. Now, if we see a case study, generally for which we solar water pumping system with having a centrifugal DC monoblock motor pump set of 1 horsepower capacity, it delivers 65,000 liter per day of water from a suction head of 7 meters and a total head of 10 meters. And it requires a solar PV panel of 900 watts for running it. For irrigating 1 hectare of land, with this set, when we compare it with 1 horsepower of pump and 2 kVA DG set, we see that if it runs for 1000 hours a year, that is 5 hours per day for 200 days in a year, we save the annual diesel expenditure of the rupees of 41,000. And since the cost of this solar PV water pumping is around 2 lakhs, the payback period is around 4 years. So it is one of the application which can be used by the farmers, and some of the farmers are using it, especially where we have a limitation of the power supply. Another application is the generation of power through solar energy. Now there are 2 ways to use the solar energy to generate power. One is through photovoltaic and another is through thermal energy. In the photovoltaic, the direct conversion of sunlight into electricity. So here we have solar arrays, we have inverter, transformer, and it can be connected to grid or it can be connected to the battery bank and be a standalone system to provide the power to the utility, or it can be a thermal system where we use the heat to generate electricity. Here we have in the thermal power plants, it contains a collector field, turbine, generator, cooling tower and transformers. The solar system, it illuminates the solar cell in the PV array, which converts the energy of the sunlight into electricity. This electricity goes into inverter since it is a DC electricity, so it is converted to AC and then it is fed to the power lines and it can be used at our residences or in the system. In our institute also we have installed the solar PV plant of 50 kilowatt capacity, and basically it converts DC to AC. Its system include inverter and or it can have a batteries to store the energy, and backup generator also is there. And so in our institute we have installed a 50 kilowatt grid interactive power plant in February 2014, and it has been installed through Chandigarh Renewable Energy Science and Technology Promotion Society under Department of Science and Technology, Chandigarh. It gives more than 200 units per day, this plant, and the cost was around 50 lakh rupees, and we are to receive 30% subsidy from Government of India, since Government of India is promoting the utilization of solar energy. And it has 10 photovoltaic strings, and we have 30 kVA and 20 kVA inverter. And there are 200 solar panels, and each panel is rated at 250 peak watt capacity, and the output voltage is 3-phase 415 volts. Another type of solar power plants is the concentrating type of solar power plants. They use lenses or mirrors to focus a large amount of sunlight into a small concentrating beam. The concentrating heat is then used as a heat source for the conventional power plant, and the technologies used for harnessing or utilization of this solar energy is parabolic reflectors or concentrating type of linear Fresnel reflectors. So these solar thermal plants, they use the sun's rays to heat the fluid from which the heat transfer systems may be used to produce the steam. Here the fluid can be either oil or even the molten salts are used, and the steam in turns is converted into the mechanical energy to run a turbine and into electricity from a conventional generator which is coupled to the turbine. And they use concentrated system due to the high temperatures needed for the working fluid. Now, solar thermal power, it consists of large field of single-axis tracking parabolic trough collectors, and the solar field is modular in nature and is composed of many parallel rows of solar collector which is aligned in the north-south horizontal axis. I just want to say that one thing is there that they should always face the sun. So that is why in northern hemisphere, like in India, they are always facing south, while in the southern hemisphere, like in Australia, they should face the north. Now, a working fluid is used to generate high-pressure superheated steam, and this steam is then fed to the conventional steam turbine or generator to produce the electricity. Here, as you see that all the concentrators, they concentrate the solar energy to the top of the tower, where the working fluid and the generation system is there. Now, another is the parabolic trough type of system. This is also having a parabolic type of shape, trough shaped mirrors, and we have a tube which is on the focus of this parabolic troughs, and they typically they concentrate up 80 times the solar energy which is received, and this light is absorbed tube in a glass vacuum tube, and it is carried away by the heat transfer fluid, and this hot fluid is used to run the steam Rankine cycle or stored for the later use. This power towers, they're the field of mirrors which are heliostat. They focus the light on the top of the tower. Here the concentration is quite high. It is typically 500 to 1000 times the concentration of the solar energy being received. And light is absorbed by the metal tubes. It is carried away by the heat transfer fluid. We have water or steam or nitrate salt. And the hot fluid is used to run a steam Rankine cycle or stored for the later use. Now here the large area is required to trap this solar thermal energy, and one of the example is installation of 10 megawatt solar power plant, thermal solar power plant in the state of California in USA, which is having around 1900 heliostat, and each is having 20 feet by 20 feet area, and it has a center tower of which is quite high, is 295 feet high. Now another technology which is used to tap the energy from the sun, it is the dish or Stirling engine. Here also it is concentrated type with having mirrors which is made up of parabolic shape, and generally we have 10 kilowatt capacity, and the area required is 1 acre for 10 machines of 25 kilowatt capacity. This picture shows that it has a panel with lot of mirrors which are focusing or concentrating the light at the focal point where we have working fluid to extract this heat for generation of power. The mirror array is mounted to the hub which contains the support bearings, the drive motors, and the simple mechanism for tracking the sun. And there are two motor driven subsystems. One periodically moves the array to follow the sun across the sky throughout the day, and another adjusts the tilt for the seasonal variations. This shows the line diagram and how the tracking system is there. There's a pyranometer which senses the direction of the maximum solar radiation, and thereby the signal is given to the control unit, and accordingly the collector is moved so that it should always face the sun, and we can trap the maximum amount of sun energy. This dish Stirling, it has it concentrated lights up to 1000 times on the receiver, and which receives the heat from the solar energy and heats the working fluid to drive the Stirling engine. And it has got a high efficiency, more than 30%, but the cost factor is one of the hindering factor for its adoption. So these are also commercially available. The sizes ranges from 3 to 25 kilowatt. So this chart shows the comparison of the various technologies. The The operating temperature are the highest in dish or Stirling engine as compared to power tower or parabolic trough, and but the power generation we can achieve to a higher extent with regards to power tower and parabolic trough. Plant load factor, that is how much energy is utilized, what is the amount of the time or what for employing this type of technologies for getting the energy. Here the dish type of or Stirling engine type is having the lowest plant factor and as compared to the power tower or the parabolic trough, and cost is also higher in this Stirling type or dish type of trough. So we'll conclude this session by discussing about the benefits of the solar energy. One is that because it arrests the pollution, that is, it do not create any pollution. Around 70% of our pollution, that is sulfur dioxide, nitrogen oxide particulates, they comes from the usage of fossil fuels for generating electricity or for other purposes like hot water heating or space heating. But when we use the sun energy, it do not emit any air or water pollutants, and there is no waste. It do not produce any greenhouse gases, which are linked with the global warming and climate change. And it doesn't require the energy supplies to be imported from the insecure region. You see, in our country, we import more than 70% of our oil to meet our energy demand. So if we harness this energy, which is abundantly available in our country, we can save that much amount of you can say our reserves for doing it for other purposes of development of our country. However, the limitations are attached with utilization of this technology. The one is that it is intermittent in nature and variable manner, which it arrives on the surface of the earth. Like, we cannot predict how much energy we are going to receive throughout every hour in the day and also in the various seasons. Another thing is that it is diffused or very dilute in nature, so we require a large area to collect it at a useful rate. And but still we have a lot of scope to use this energy because we have got abundantly available sun in our country. That is why our country, we have launched a scheme that is known as Jawaharlal Nehru Solar Mission, which was launched in 2010. It aims to deploy 20 gigawatt of grid connected solar power by 2022, and also to provide 20 gigawatt of off-grid solar applications, including 20 million solar lights by that year, and install 20 million square meter of solar thermal collector area. So based on that, certain various initiatives have been taken at the state level, and we have installed the solar PV plants as well as solar thermal appliances throughout our country. So thank you so much, and if we have any question, answer, we can discuss it now.
Hello, ma'am.
Hello.
I am Manu Singh from MIT Muradabad.
Okay.
Ma'am, I want to ask that how the hello.
Anji.
How as the PV cells are so much expensive, then how the cost can be reduced to use in the home appliances and in buildings?
You see, the cost depends upon the material, and it is very the process of extracting the silicon, because it is generally available in the sand, the silicon. It is very high. It is very cost intensive. So a lot of research and development work is going on in that area. So it is not like that I can just tell you how it can be done, the cost can be reduced. So that lot of research is going on. You see, previously when the solar PV came into picture in around 1950s, the efficiency was just 4%. And now we are getting around 17% of efficiency from these solar cells. So you see, over the years, the research has taken place. That is why we are getting the efficiency. And this is one of the major area of concern and of research throughout the world, how to reduce the cost. So that is another. And as for your question regarding usage of solar photovoltaic appliances in your home, the best application is solar photovoltaic lantern or light, which I have seen myself also, because in our institute we have certain demonstration of solar PV lanterns and they work very nicely, especially in the remote regions where there is a lot of power cuts. And some of the participants of my earlier courses, they also felt quite good. Especially, you see, I can share experiences of one or two participants. They came here and they attended my earlier courses, and we took them to the industries or to the places where these appliances were being manufactured, and they were so happy. They brought that lantern, and during the final exam of their children, like board exams, the power cut was there, but they used the solar light and their children could study during that crucial time. That is one of the application which you can also use for that. Like solar calculators is another application which you might be using also. So any question? Another?
Hello, ma'am.
Yes. Yes, sir. From which center are you from?
Hello, I am Bhairav Dubey from IEC College.
Okay.
मैं ये प्रश्न करना चाहता हूँ आपसे।
हाँ जी।
यदि किसी सोलर सिस्टम को हम इंडिपेंडेंटली स्थापित करना चाहें अपने घर में अपने पूरे पावर रिक्वायरमेंट के लिए,
हाँ जी,
जिससे कि हम गवर्नमेंट के जो पावर सप्लाई हमारे घरों में आ रहे हैं उस पर निर्भर नहीं कर रहे हैं हम, तो क्या ये संभव है? और यदि ये संभव है तो खर्च कितने आएंगे और कितना ये लायबल हो सकेगा?
Very you can say very question, relevant question, but the problem here comes is जैसे चंडीगढ़ में भी स्टार्ट की हुई है ये स्कीम DST ने, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी ने, और जैसे मैंने आपसे डिस्कस किया था ग्रिड कनेक्टेड भी है और स्टैंड अलोन सिस्टम्स भी है। जो थंब रूल है, जो ग्रिड कनेक्टेड सिस्टम है, जैसे कि आपने देखा भी था स्लाइड्स में, द कॉस्ट कम्स आउट अराउंड 1 लाख पर किलोवाट। ठीक है, अगर अपने घर में अगर हम ले लगाते हैं तो अगर 2 किलोवाट का लगाएं, 1 या 2 का, तो 2 लाख पड़ता है हमारे को इनिशियल इन्वेस्टमेंट। तो जनरली आई हैव सीन, जो भी मुझे फीडबैक मिला डोमेस्टिक से, एक तो हमारे पास रूफ एरिया बड़ा होना चाहिए एंड शेडो फ्री होना चाहिए, दैट इज वन ऑफ द रिक्वायरमेंट टू इंस्टॉल द सोलर पावर प्लांट। एंड इफ वी पर उसमें ये प्रॉब्लम है ग्रिड कनेक्टेड में, जब हमारी मेन इलेक्ट्रिसिटी का पावर कट होता है तो जो ग्रिड से कनेक्टेड हमारी पावर जनरेशन है, दैट गोज वेस्ट। It neither goes to grid or neither it is transferred to our home for meeting the energy demand. तो उसमें क्या करते हैं, another option is when we connect the storage batteries with the system. अब क्या होता है, जब बैटरीज हम करते हैं तो प्रॉब्लम इज मेंटेनेंस एंड कॉस्ट। इनिशियल कॉस्ट अगर हम बैटरी वाले स्टैंड अलोन सिस्टम में देखें तो इट कम्स आउट अराउंड 1.5 लाख पर किलोवाट, सो दैट इज क्वाइट हाई। सो इट कैन बी इंस्टॉल्ड, you can but the cost factor is the major hindrance to the installation of such plants. Like in Chandigarh also, government has they have started the net metering system, even in Punjab also, but the again is the investment. एवरी जो भी हमारे जो रेजिडेंस में जो इंडिविजुअल कस्टमर्स हैं, वो जब उसकी कॉस्ट का सुनते हैं कि हमारे को 2 लाख 3 लाख खर्चना पड़ेगा इनिशियल इन्वेस्टमेंट, सो देन दे थिंक no, it is better to use electricity which is coming from grid rather than using this system, right? So presently अगर हम economically feasibility देखें तो it is not going to give you that much output, but of course if we see the environmental this thing benefit, then it is going to help the reduce the greenhouse gas emission. So that is the major factor associated with this technology. Although you can see if you can financially you feel that you want to invest so much money, then there are agencies who are working and there are various industries who are installing the solar photovoltaic plants.
गवर्नमेंट की तरफ से ऐसा कुछ आर्थिक सहायता मिल सकता है क्या?
गवर्नमेंट की तरफ से आप लोन्स का है कुछ, एंड बाय बैक ऑल्सो उनकी जो वो है वो आपको इट वेरीज फ्रॉम स्पेस टू सॉरी स्टेट टू स्टेट, बाय बैक उनकी क्या क्या कॉस्ट है, दैट यू हैव टू चेक। तो वो आप देख सकते हैं, इफ यू फाइंड दैट यू कैन इन्वेस्ट योर मनी इन दिस इंस्टॉलेशन, then you can check about that. And one more policy is there, it is not concerned with the residents, because residents पे हमारे को बहुत कम power generation मिलती है, क्योंकि हमारा rooftop area कम होता है, limited होता है. while अगर हम बात करते हैं उसकी
आड़ी गाजियाबाद ये जो विधान है ये है हमारे
Okay. बट आई वाज जस्ट सेइंग कि अगर हम बात करते हैं दूसरी कमर्शियल बिल्डिंग्स की या इंस्टीट्यूशनल बिल्डिंग्स की, तो एक नई पॉलिसी है गवर्नमेंट ऑफ इंडिया की, इसमें लीज पे दे सकते हैं अपने रूफ को, दैट लाइक industry they can install their own solar photovoltaic this generation power generation systems, and then they can give you per unit they cost throughout the year for say minimum 10 years or so. So roof can be given on lease. They will install invest all the finances from their side. That is another scheme. So maybe at your institute or somewhere you can plan about that, so that will be financially more viable.
नमस्ते मैम.
हाँ जी, नमस्ते जी.
Thanks a lot.
हाँ जी.
Hello.
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 Yes. हाँ, you are audible.
I'm from PUB Siddhartha.
From where? Which college?
PUB Siddhartha, Andhra Pradesh.
अच्छा, हाँ जी. हाँ जी.
I have read an article about space-based solar power.
Okay.
That is implementing in our country in Tamil Nadu. Is it in progress or not? I want to know.
I did not get your question. Can you please repeat it little bit slowly? It was fast. I could not understand it.
I have read an article about space-based solar power. Yes, space-based solar power.
Okay.
In our country, it is implementing in Tamil Nadu. I have read it in somewhere.
Very good.
Is it is it in progress or not? I want to know that.
Yeah. The government is promoting this solar energy and research and other space-related programs also. So I'm sure that work is being done in this direction.
Thank you.
Yes. Any other question? From any other center? No. So we'll break now for lunch and we'll meet after an hour for the next session. Thank you. आपके तरफ से क्वेश्चन है? मैं बीच में पूछना ही भूल गई. ये हमको कुछ था ट्रैक
कैमरा ऑफ कर दो तो नहीं है तो चढ़ाई ज्यादा है
Good afternoon to all the participants at the different centers. I think 4 centers are connected. RTU is not connected and RD Engineering College is not connected. Hello? Kuch nahi hua. RTU is not connected now.
Only I think 4
Okay, anyway, this session, the lecture is mine only, the coordinator. So I will give you an idea of smart grid, and then again we will go on to different things about my smart grid in the next classes, microgrid and hybrid electric vehicles, then wind technology. Deepika ko de. So we'll start with smart grid. The outline of my lecture will be definition, building blocks, potential benefits, requirements, and then recently what smart grid can do for India, and then recently announced pilot smart grid projects in India also we will discuss. See, why we require smart grid in India. We all know about the Northeast blackout on July 31st. It affected almost 22 states of India and 60 crore, that means 50% of India's population, and 6 rail zones. And 3 grids, northern grid, which consists of Punjab, Haryana, Rajasthan, Delhi, Uttar Pradesh, Uttarakhand, Himachal Pradesh, J&K and Chandigarh. Eastern grid of West Bengal, Chhattisgarh, Bihar, Jharkhand, Orissa and Sikkim, and northeastern grid Arunachal Pradesh, Nagaland, Assam, Meghalaya, Manipur, Mizoram and Tripura. These 3 grids were affected. What were the reasons? The main reasons were the weak inter-regional power transmission corridors due to multiple existing outages, both scheduled and forced. Then there was a high loading on 400 kV Bina Gwalior Agra link. Then there's an inadequate response by the SLDCs to the instructions of RLDC to reduce overdrawal by the northern region utilities and underdrawal by the western region utilities. With that reason, there was a misoperation of the protection system of the 400 kV Bina Gwalior link. So with this overdrawal, there was a problem with the protection system in the link, and that created the loss. When one loss had occurred, it has aggravated the other grids also, and there was a massive power blackout. So we could really understand that smart grid is essentially a necessity for India, such a big country, interconnected with the various states and the grids. So smart grid should be the essentially necessity for India. So let us define what a smart grid is. See, when we talk about smart grid, a meter engineer may define it as an advanced metering infrastructure. It will have a smart meter or a bidirectional meter, so we can call it as an advanced metering. Then when we talk about a protection and control engineer, for him it is a substation and distribution automation. So there is an automation in the protection and control methods. Then for a control room operator, it is an outage management. Whenever there is an outage in the system automatically manages the distribution and outage management. And to a design and planning engineer, it is an asset management, whether we require more assets, more transmission and distribution lines, more substations. So the design and planning engineer, it is an asset management. So then, what we can say, in addition to all this, there is another area of networking. All this, what we were defining in the previous slides, and more than that, into a network, all the electrical assets and the other things together, bringing together. So there is an IT expert also should be there, so that networking of all this. So all what I have explained in the previous slides. It is asset management, it is outage management, it is advanced metering structure, and it is a network of all networks, various managements and a network of all. So that is what is actually a smart grid. So there are two infrastructures here. One is that electrical infrastructure. We have substations, we have transmission and distribution lines, towers, step up and step down transformers, and then the distribution lines and the consumers which we take it. We know that electrical infrastructure along with an information infrastructure. So we can define it like the whole electrical network is again have an interconnected IT network also along with this. So we have all those information infrastructure also. So what is the result? It increase energy and operational productivity, it increase power reliability and quality, and out of all, it reduce carbon dioxide emissions. So it is an integrated system solution to a complex set of challenges. Now we will see one by one how this can be done. So Wikipedia defines smart grid like this. That's an electrical grid that uses computers and other technology, okay, to gather and act on information. Okay, now it was the electrical grid was not having much computers. Now we have a technology to gather all the information there. So what are the information we are going to gather? About the behaviors of suppliers and consumers in an automated fashion to improve the efficiency, reliability, economics, and sustainability of the production and distribution of electricity. I'll show you a small video which will make it clear what a smart grid can do.
Envision a self-healing network that can greatly reduce power outages for our customers. Duke Energy can make this possible through smart grid technologies. Smart sensors placed along our power lines and in our substations can detect trouble and communicate real-time information to automatically diagnose problems on the line and reroute the power supply. So how will a self-healing system work? Let's take a look. Here is a community made up of residential, business, and what we call critical need customers. You'll notice that the homes, the shopping center, the school, and the hospital all receive their electricity from power source A. You can also see power source B, which serves the southeast section of town. Now notice switch 1, switch 2, and switch 3. These intelligent switches can automatically detect trouble on the lines and then stop, start, or reroute the power flow in order to isolate the problem. Let's see what happens when a vehicle accident occurs. An automobile is traveling east. The car hits a slick spot on the road and strikes a utility pole, damaging the pole and the power line. Today, without smart grid technology, power source A would shut down, and the entire community, including the shopping center, homes, school, and hospital, would lose power. The power would remain out until a customer notified Duke Energy and crews were sent to make repairs. However, with smart sensors and control technologies, switch 1, switch 2, and switch 3 immediately detect the problem. As the car hits the pole, switch 1 senses an abnormal power flow caused by the damaged power line. Switch 1 then communicates with switches 2 and 3, and switch 1 and 2 open up to stop the flow of electricity and isolate the section of line between them. Power source A is now providing electricity to the shopping center. Switch 3, which is normally open from power source A, closes in order to provide electricity from power source B. Power source B is now rerouted to deliver power to the remaining community. Power continues to flow to most area homes, the school, and the hospital. Only the customers served between switches 1 and 2 have lost power. While this animation has been slowed down to allow you to see a series of events, this self-healing process would actually occur in just a few seconds. In fact, customers may notice only a brief blinking of the lights as the smart grid automatically isolates the outage and keeps power flowing to the greatest number of customers. The smart grid also automatically notifies Duke Energy's Power Delivery Work Center, which can quickly send a repair crew to the area. The crew makes the repairs, and then the Power Delivery Work Center remotely restores the power flow to its original state. A smart grid that can monitor itself can change the way Duke Energy does business. From improved reliability to faster restoration, we can use smart grid technologies to better serve our customers' needs.
I think now this video had made it clear how a self-healing system works in a smart grid. Okay, so now we will see. I don't have to explain it. I think it was very clear to you. I will see what are the various parts or building blocks of a smart grid. Okay, see, the main items in a smart grid are the new grid structures, which is defined as the distributed generation. We have a very detailed lecture on distributed generation in the morning. Combined heat and power plants, plug-in hybrid electric vehicles, photovoltaic cells, that also we had a lecture today. Wind turbines, we will have lectures on hybrid vehicles and wind turbines in the consecutive next days. So these are the main grid structure components in a smart grid. Then there are various sensing and control devices like sensors, intelligent electronic devices, smart meters. In addition to that, we have communications infrastructure like networking infrastructures like fiber optics, microwave, infrared, power line carrier communication, GSM communication, CDMA, etc. Then automation, IT backend, high-end servers, middleware, data storage and data management system, and at the end, advanced analytical applications, okay, which can do what we have heard, that self-healing within microseconds or milliseconds. Okay, see, this is a again descriptive picture of a network like this. See, this area is a home end network, area network, where we have our home appliances. Then we have a neighborhood area network, or we can have it as an advanced metering infrastructure which will meter what you have consumed at your home. And then this is the distribution area network, which will distribute from the transmission lines, step down transformers to our home areas, and utility core systems, where these are connected to various networked computers. In addition to this, we have other applications also here. We have a PHEV, hybrid electric vehicle, power quality sensors, distribution automation, outage management. We have relays and other circuit breakers, and mobile applications, which will also help us in doing all this distribution area network and utility core systems. So in a way, we can call it as a network of networks. Okay, that same explanation which I have given you is given here again in a different way. The upper area, where we call as the electrical infrastructure, which we have seen in a slide before, and these are the information infrastructure and other energy services infrastructure. Now see, this is the smart grid network, and we have various network adapters throughout. This is the home, where we have smart appliances, load management. Then in each of the houses we have self-generation these days. Then distribution, customer service, work management, outage management, these are come in the distribution area network. The transmission services, we have self-healing, system control, that stability control and things like that, outage management. And the generation, we have the normal energy sources, energy services generation. In addition to that, distributed generation, renewables, asset optimization, everything will be there in this. And we have another set of energy services, regulatory services, and financial markets and RTOs working on the other side. So these are all the various information flow which the smart grid network get from various sources or various connected networks along with this. We have seen in the previous slide. I'm sorry. We have seen in the previous slides that it is a network of networks. So it will have all this information flow to the smart grid network in such a way. Okay. See, when we talk about a modernization, when we describe what a smart grid is, see, like, we should understand, we know what is today's electricity system. We have great generating stations like a thermal power plant or a hydroelectric power plant, and from there we have step up transformers, transmission lines, and then various levels of consumers. Some are high voltage consumers and some are normal distributions, and then we have factory like consumers. But here in a modernized smart grid, it is not that the power flow or electricity flow is from one side. It is a one-sided flow from the generators to the consumers. Here there are various distributed generations. See, we have wind farms, we have rooftop photovoltaics, smart substations, combined heat and power. Then we have heard about SMEs, storage devices, and various in the remote loads also along with this, industrial loads, remote loads, and we have power parks. So, and in addition to that, we have the normal generating stations. So here it is, and along with it we have hybrid electric vehicles. Those are plug-in electric vehicles also. So in all this way, today's in the coming days, our electricity, the system, the grid is not a one side flow system. It is a combination of various distributed generations and the smartness in the substations and in all the other resources also. Okay, so this is another way it can be represented of a smart grid. There are various renewables, wind farm, nuclear power plant, and a smart substation here, which can manage these all these renewables and normal generating stations. And then we have a smart buildings, sensors, smart switches. All this will combine a smart grid. So now, what are the, again we'll go into some more components. These power system devices apply the latest research in materials, superconductivity, energy storage, power electronics and microelectronics to produce high power densities, greater reliability and power quality, and enhanced electricals. So these are the result of what we have seen in the previous slides. Now, how is it different? See, I have two columns here, the existing grid and the smart grid. See, existing grid is electromechanical, whereas the smart grid is more of digital. Okay, this I have told you, it is not that it is a one-way communication, that we receive power, the consumers receive power every time. In a smart grid, the consumers can produce power and supply to the grid also. It is in an existing grid, it is a centralized generation. In some areas we have the generation, but in smart grid we have the distributed generations. Okay, and there are failures and blackouts, but in we have seen that self-healing system. It is adaptive. It finds out the faults and island the area of fault. In existing system, there are only few sensors, but the smart grid, there are sensors throughout, and it is self-healing and self-monitoring, and remote check and test is there, whereas in the other one, there is the self-healing and self-monitoring are not there. It has manual restoration, manual check, and there is the whole system is hierarchical. After the generation, the transmission give our distribution. So that hierarchy is not there in smart grid. It is all a network connection, and the control we have in existing grids are limited, whereas in smart grid there is a pervasive or very control also there. Okay, now we'll see what are the various technologies we have. There are integrated renewable energy sources, hybrid electric vehicles, where we have connection from the grid to the vehicle for charging the vehicle, or else from vehicle to grid also. Whenever there is a shortage of power, the charge from the vehicle can be supplied to the grid, so that it is in both ways, grid to vehicle and vehicle to grid technologies. High voltage DC and fax. Fax is flexible AC transmission systems. We require fax devices for the system stability and other quality power also. So that also we can have these technologies also. Then in addition to all the other information systems, we can have a weather condition information system. This is very much important because our renewable energy technologies like solar and wind require the weather condition information systems prior to it. So if we know that tomorrow there is no sun, we don't have to depend on the solar PV, the power which it generates. Similarly, so the weather condition information system is also very important, an important technology we require in a smart grid. Then demand control response, it is depending on the demand control that is very much there in otherwise also. Demand side management. SCADA is supervisory control and data acquisition. There is always a supervisory control. The data are acquired from various sensors throughout the smart grid, and a supervisory control is applied to it. And in addition to this, there is a geographic information system also, because the smart grid is not for a particular city. It is for our country. The whole country requires it. So the whole grid, if you think about the Power Grid Corporation of India, it is a grid which is connected the whole country. We have various grid areas. So we require a geographic information system also within this smart grid. And then in addition to this, energy storage options like battery, SMEs, sodium sulfur battery. So energy storage is also very important in case of a smart grid for it to be smart. So microgrid and virtual power plant. I'll show you a film on a microgrid, and you will have a concept of it out of this. And tomorrow we'll have a different lecture on microgrid actually. Okay, you can see how what is a microgrid.
In remote regions of the world, power grids are often intermittent or non-existent. Aid relief camps and military forward operating bases, among other sites, cannot rely on this fragile source of power. New solutions are needed. Precious fuel is trucked in to keep FOB bayonet's generators running. Convoy protection over the past days has taken its toll.
This is an operating base of an army in a remote region, and there are generating stations which is supplying this area.
When redundancy is provided, generators often run underutilized. Overutilization for a single generator is also a problem. Both cases waste fuel. Hours after the convoy arrives, fuel levels are already racing towards empty. Two of the three generators are
the graph shows that there is a fuel problem in the generators. So the generator 1 and 2 and 3 are running half load.
A mortar attack takes out generator 2, causing power.
In the meantime, one other generator was destroyed by the enemies.
Additional systems would also go down. An intelligent microgrid system addresses these problems, providing redundancy while increasing efficiency.
See, now see here, even though there is a problem, the one generator is not there, the intelligent microgrid senses and the other generators are supplying the whole system.
Microgrid system, FOB bayonet's power demand can be handled by only 2 generators.
Now there are only 2 generators.
Saving precious fuel. Power from the 2 active generators is redistributed instantly.
So those 2 generators take up the supply now.
And routes all available power to essential locations.
Now, after some time, they have started a 3rd generator also, which was a standby generator. One was destroyed, the 3rd generator was started. And as the daylight has occurred, they have installed solar panels and wind turbines. So now some of the supply has been supplied by the wind turbines and the solar PV panels. So now the 3rd generator is again switched off to the storage systems. So all this can be controlled. The whole base is not connected to any power grid. It has its own grid. That small grid is known as a microgrid. It may have distributed generations. It may have diesel generating stations. So it has a renewable energy stations, distributed generation stations, like it has the video which we had seen had a solar PV cells and wind turbines also, and they were having a standby diesel generating station also, and there were 2-3 DG sets also. So even if one was destroyed, the intelligent microgrid could take up the other, switch on to other 2 generating stations, and the standby generating station is also switched on. So it is a small grid which work like a power grid, but then it is a remote location where you cannot be connected to the power grid of the system. So it is a group of interconnected loads and distributed energy sources within a clearly defined electrical boundaries. So it is not connected to the main grid, acts as a single controllable entity. So it is not that it cannot be connected also. It can be connected or disconnected. So there are 2 modes. One is grid connected or island mode. So a microgrid can be connected as a grid connected mode or islanded mode also. So here we can see an islanded system or a micro connected system. See the ellipse up here it is shown as the large grid, and this is the system interconnection. This whole lot is a microgrid. So if this connection is not there, we call it as an islanded mode, or if this connection is there, then we call it as a grid connected mode. So this microgrid has loads, diesel generator, wind turbine, photovoltaic panel, battery storage, all these types of distributed generation, along with the loads which it has to supply. Now we'll go to some more benefits of smart grids. The it increases the efficiency. We write the operational efficiency. We call it as reduced on-site premise presence. Outage durations are shorter now. It will work in microseconds.
Hello.
Yes.
Sorry to interrupt you, madam. I am from Modi University.
Yes.
Madam, island mode is a desirable mode of operation, or it is to be avoided while operating a smart grid?
No, see, it is. There is nothing like that. You cannot operate on islanded mode. Like the case which we had seen in the video, there is no possibility of a grid connection. to a larger grid or the supply grid which there. It is a remote location like we have in Leh, Ladakh or any other hilly areas. We cannot have supply grids over there. So in such cases, islanded modes can be done. There is no problem. But then grid connected has, like in the morning class we have heard that reliability problems will be solved. Reliability will be more if you have a supply grid connection also. So it depends from location to location, situation to situation, that you can have islanded mode. There is nothing like that you cannot. Is it a desirable operation or not? I think it is clear to you.
Thank you, madam.
And then the third point, it is written as optimized transformer operation. Like the transformer will not be overloaded. The loads are, more loads will be supplied by the distributed generation also here. Standards and construction, it will improve the network operations, it will reduce the integration and IT maintenance cost, and condition-based asset maintenance and inspections. That is again, that all these comes under the operational efficiency. When we talk about energy efficiency, we can see that there are the losses are the main point here. And when we have the proper type of management, the active and passive demand side management and all, the efficiency will increase. And the most important part is the customer satisfaction. As we all know, the more outage duration, the more unsatisfied the customers are. So it reduces the outage duration, and in such a so that the customer will be satisfied. And it can have call center and call centers which will support the customers, and it will reduce the call center inquiries, and also revenue collection will be improved. So having a smart grid, it is not that the automatically the revenue collection and things like that can be done in a smart grid. I'll give you a little bit interesting examples afterwards also. And it reduces greenhouse emissions, delayed generation and transmission and capital investments. I'll show you a interesting picture over here. See, if Alexander Graham Bell were somehow transported to the 21st century, he would not recognize the components of modern telephony, smartphones, texting, cell towers, etc. While Thomas Edison, one of the grid's key early architects, would be totally familiar with the grid, because what he has envisaged is what is happening even now. How we are familiar with smartphones and cell towers and various technologies and apps, that is not there in a power grid. So that is what I'm saying. We have to have change in such a way that our grid is efficient. Means we can make revenue collection also automatically. Now how we pay the bill of our phones, automatically we pay bill. We have apps for almost all things. Whereas why can't we have a power management app also? So thinking of in all these ways, smart grid is an important entity that we have to think about. So there is potential financial benefits also are there because of operational efficiency, environmental impact, all what we have seen in the previous slides. The financial benefits also will be improved. So now here the consumer is not that I sit here and consume. No, he is also a producer. Like, you know, distributed generations, we have seen that each of the customer, a person can have a rooftop photovoltaic, so he can have a fuel cell, he can have a energy storage. So he is a prosumer now, he is a producer as well as a consumer now. So all those when combined together, the satisfaction and the financial benefits for both ways, suppliers and the consumers, increases. This we have already seen in a different format. Okay, now let us, what we have already seen, again I put it into a interesting slide. It is self-healing to correct problems early, fast, interactive with consumers and markets, optimized to make best use of the resources, Like we have various types of resources, solar, wind, and all those resources have been used properly. Predictive to prevent emergencies. Yes, it can predict what will all happen in the emergencies can happen. Assets and informations are distributed and it all integrated together to merge all critical informations and secure from threats from all hazards. So all these properties which we had seen now will be combined together in a smart grid. But then, why are we not coming into it? What are the main barriers that happens while we think about the development and implementation of a smart grid? One of the main point which we define is the cultural barriers. See, in for our country, as we know, there is a big cultural barrier. We have some different states, different governments, and different money involvement. So cost of development and implementation, it is very costly, that is true. High levels of uncertainty. Even now when we speak about it, means it looks very costly, but how to do it, we are not very clear. There is lots of uncertainty throughout how we can do it. Similarly, regulatory risk. As we all know, the whole electricity market has various regulations, and those regulatory risks also will come into picture. Cyber crimes, okay, that like the cyber crimes in any situations we have with cell phones and others, networks, internets, here also it can happen. Once it is having an IT infrastructure, network of networks, such things can also happen. People can easily steal power and not pay money. All those things is very easy now, only have to do some hacking and things here and there. Burden of operating and maintaining the solutions, vested interest. Each bureaucrats or otherwise have some vested interest. They may think this should not happen. Increasing customer awareness. See, that is again a big problem. Now we don't know what is happening. We are afraid to touch the electric lines. So some electrical operator should come and do it. Now when that thing is not there, awareness increases. You can do things by simply sitting on a computer, and the participation of the consumers. I told you the consumer is a prosumer now. He also produces, he also supplies, so he is also a generator, so he also has to get money. It is now here, it is like you always pay for the electricity you consume. Now you generate electricity and supply, means you are getting some money. So all these participation and awareness of consumers will also generate lots of problems. So all these barriers is what are not making it happen. Okay, now let us see how it can be done for an Indian system. See, like as we all know that a growth rate of around 8% GDP, India's energy demand is expected to increase 3 times in the coming 10 years. The population is increasing, the requirements are increasing. So 2/3 of which would be carried by the grid, and rest 1/3 will be directly used. Okay, so to enable a similar growth, it has to do a major revamp of the electricity system from the transmission to the distribution. So we require mainly renewable energy sources. So these are all the various challenges it is going to face. Shortage of power, power theft is again another big challenge which we could not control. Poor access to electricity in rural areas, mainly the rural areas which are mountainous, hilly regions. Other rural areas, there even then we can say that there is access to electricity, but then the hilly areas, hilly regions of our hill states of our country, the rural areas, there have really poor access to electricity. Huge losses in the grid. See, when we talk about huge losses, the actual situation is mainly because of the power theft only. It is not that we are having that big losses in our transmission and distribution lines. That is also due to the power theft only. Inefficient power consumption and poor reliability. Poor reliability, we know that because of the population only, less supply, more demand, we are not having that reliable power supply. So this was the slide which I had shown you. Thomas Edison, if he comes back to the 21st century, we have the same old bulb, we have the same old wires and same old type of wiring systems. So, but then in the telephony system, it had a big change. So the present grid system needs a major revamp. What are all? Increasing generation capacity, improving grid efficiencies, rural electrification. So a smart grid is the solution to all this, India's energy security in the future. See, the government is also having various programs. The very common and known program which we have is the Accelerated Power Development and Reform Program, RAPDRP. Another one is the Jawaharlal Nehru National Solar Mission and Rajiv Gandhi Gramin Vidyutikaran Yojana. According to this RAPDRP, see, another thing is, like I was telling you in another slide, see, we should have a power management. We can have various centers. You have thinking about your research, your students are also working. Why can't we have a power management app which has various options like smart meter reading, safe house, smart automated devices, power account management, what is our account number, and we see we have net banking these days, but we don't have any account of our electricity usage, how much we are using every day, what money we have to pay, what is the tariff. Many of us do not know our tariff also. What is the unit rate? So if we could develop an app, a power management app, so India has an opportunity, lots of opportunity where you can work in this area. So government itself has announced various smart grid projects. Some of them I will list out here. I'm not going to read all the details. Almost 14 projects have come up in this RAPDRP in almost all states, one by one. I'll only show you the states and the projects. One is in Haryana, Panipat city subdivision, UHBVN Haryana ki under mein hai. Project number 2 is in Mysore, additional city area division, CESC Mysore ke under hai, involves 21,824 consumers. Residential, commercial, industrial and agriculture, many of them advanced metering infrastructure, all those things are included in it. Then the third one is in Agartala, and it is electrical division number 1 at Tripura. Kerala also, some selected distribution section offices in that Kerala state area under KSEB Kerala. Then we have one in Puducherry, Electricity Department, Government of Puducherry for 87,000 consumers. One is in Gujarat, Naroda and Disa areas, sections. This project proposes around 20,000 consumers. This also have power quality management, outage management, AMI, industrial, commercial and residential consumers के लिए ये government ने plan किया हुआ है. In Jidi Methla in Andhra Pradesh, Guwahati, the main things are almost same only: outage management, peak load management, AMI, distributed generation. Then Maharashtra, Baramati town, Chhattisgarh, हिमाचल प्रदेश में इंडस्ट्रियल टाउन ऑफ कालाअंब, and Punjab mein it is Amritsar. Today actually the Chandigarh government also had announced a smart grid project in Chandigarh also. In today's newspaper I read it, and it is in that it was clearly written that in the RAPDRP Chandigarh did not get a project. It has gone to Amritsar, but then the Chandigarh MP has given one project for the industrial area of Chandigarh. So government is in the process. Government has understood that this is very much important. So what the plan is that we can have smart grids at various locations, small separate locations. If we could have it, then you can expand it to nearer locations, and then at the end we can have an interconnection of all this. So this project is at Darjeeling and another one in Jaipur. These are the 14 projects which has been announced under RAPDRP scheme, and almost all this, if I read through all this, almost all these are for the outage management, automated metering infrastructure. So here the main idea is the metering. Metering is also a very important part of it. See, as I told you, power theft is a very important concern and challenge for the utilities. So if we have smart meters installed in the consumers, then the revenue will also improve and smart metering structures will also come. Whenever we think about smart grid, the metering has 2 points. One is, the main thing is that it is a bi-directional metering. We consume the electricity, the amount of electricity consumed, what is recorded, and we pay for it. So if the particular consumer is a producer, he has a solar rooftop, and the rooftop generates more than what is his demand. So the consumer can now supply to the grid. So for supplying to the grid, the same meter will now measure the amount supplied to the grid also. So the meter now meters the amount of energy consumed and the amount of energy supplied. So in many cases it may not be required that maybe the consumer may get more money than what he has spent. So that infrastructure, a metering infrastructure, so we require to have intelligent and smart meters also to be installed in a smart grid. So we can hope in the coming days with these various projects of the government of India, it comes up in a slower pace. Even then, if we really work on it, there are industries working on it, on various requirements where we have, and meters are all have come up nowadays, and the residential consumers and industrial consumers have to come up. Lots of IT engineers are required here. So many a time smart grid, when we think about electrical engineers, and we electrical engineers know that electricity part of it, but many IT engineers are also required to prepare that network challenge which we require in this also. Then there are various projects throughout the world. Australia, Canada, South Korea, all the countries throughout the world are into it. Recently, last year I had visited US, and there also I went to a university, and research is going on in smart grid. So I was under the impression that in US something might have been happened. हम इंडिया बहुत पीछे है, तो मैंने सोचा हमारे इंडिया में ये सब नहीं होता है. But while discussing with them, they are also on the in this project only. It is not that in US also it is all set up. they also have started installing smart meters, bidirectional meters, and then get all these details into the electricity authorities, so that they can design intelligent smart grid options. I have seen in the electrical engineering department there are computer science students also working in the computer science research school, who have done their BE and masters in computers, are working in the research in smart grid. So that requirement is also a very important requirement, which is not very much done in India. इंडिया में हम सोचते हैं इलेक्ट्रिकल इंजीनियर्स का काम है स्मार्ट ग्रिड का, नहीं, इट इज अ कंबाइंड प्रोजेक्ट ऑफ वेरियस denominations, various engineering branches. So now let me conclude. Any questions you have in between? Any centers have any questions? Okay, let me conclude. Many smart grid technologies are in development stage with only a little available to be deployed. Implementation requires significant investment. If it is to make an impact, it requires significant investment. Regulatory acknowledgement is also needed. Indian electricity rules and all that have been framed in such a way that the distributed generations are to be taken up. You have heard about it in the morning classes, grid codes and things like that. So there are regulatory acknowledgements. There is still plenty of work for the research, development, system builder, implementation communities in both transmission and distribution. So this is an area where students can take up research, master's, PhD.
Madam,
Yes.
there is a question from MIT Moradabad.
Yes.
Yeah, I was keenly listening to the lecture, and I have understood the concepts of a microgrid. But I would like to know how a microgrid essentially differs from a smart grid.
Okay. See, there is when we talk about the characteristics or anything, there is not much difference of a smart grid or a microgrid. The microgrid is just because it is an isolated, a small area, means electrical boundary. There is a small electrical boundary around of that, so that will supply to that small area only. I had shown you, I will show you that definition of a microgrid, which I have been explaining about smart grid or microgrid also. So in the, what is the definition which I had shown you? It is defined electrical boundaries there. When I talk about a smart grid, that is an enlarged view of a grid. When I talk about Power Grid Corporation of, when I say Power Grid Corporation of India, you people have an idea of a common grid from one part to the other part, northern grid, northeastern grid, southern grid, all the grids, all the states of India are connected together. When I talk about a smart grid of India, the same way all this whole power grid is smart, where microgrid is not we cannot define microgrid. Microgrid have a defined electrical boundary. Like I told you, the example which I have shown you of microgrid is an operating army base, where it is a remote region. There is no connection or supply to the main grid, or a particular area in Leh Ladakh. The supply, to get a reliable supply there is a problem. So in that area, we can have some distributed generation, renewable energy sources of supply, and some storage, batteries and things, storage devices. We can make a microgrid in an islanded mode. Or you think that I may get electric supply but not very reliable, that can also be connected, so that I can have a grid connected microgrid also. So when smart grid is an overall idea all the characteristics of smart grid is there in microgrid also. There is
Hello.
no as such difference there.
Hello.
Thanks a lot, madam.
Okay.
Thanks a
Hello.
lot.
Hello,
Hello.
ma'am.
Hello, ma'am.
I have a question.
Okay,
Excuse
one
me,
second
ma'am.
at a time, please.
I am from IC college.
IEC, okay. Speak from
Is
IEC.
there any microgrid installed in India?
See, as such, I may not be able to tell about it. Maybe you can ask this question tomorrow to IP Verma, sir. I don't know whether we have any microgrid as such, intelligent microgrid in India. But otherwise, renewable energy sources supply are there.
Hello.
Okay.
Hello.
Hello, ma'am. I am speaking from Modi University, Lakshmangarh.
Yes.
My question is that, ma'am, can you highlight the various application of wireless sensor networks in smart grid?
Wireless sensor networks.
Networks.
Okay. Okay. Let me have a little bit study on it. Maybe there may be some applications. I have not read about it. I have not done about it. Please, I will think about it and I'll tell you. In what is your name?
Jitu Sharma.
Jitu Sharma. Okay, Jitu, I will find about it and then use it. I'm very sure that wireless sensor networks maybe will be very effectively used in smart grid. Let me think about it and then tell you within these 3 days. Okay?
Yes, thank you, ma'am. Thank you.
Excuse me, ma'am. There is a question. I am from MIT Muradabad. Ma'am, is there any difference between nanogrid and microgrid? Grid?
See, in my understanding, like when we think about power systems also, like we were defining power plants as small, micro, nano. It is the power capacity. So we have a small nano, micro power plant or a small hydro power plant and all we were defining. It is depending on the capacity. So here when we talk about a nano grid, again, it may be a smaller electrical boundary. Like I've told you now, the defined electrical boundaries or the number of renewable distributed generation may be lesser in a nano grid. That must be the way it must be defining a microgrid and a nano grid.
Okay, thank you, ma'am.
Okay, welcome.
Hello, ma'am.
Yes.
I'm from MIT Muradabad. I want to ask the difference between the grid connected mode and islanded mode. How it should be differentiated?
Island, the word island means like you have a tapu in a sea. It is an isolated entity. Okay, so when it is a connected mode means there is a connection between these two. So here I am showing a picture of clearly an islanded mode and a grid connected mode. See here we have a micro grid. This bigger circle is shown as a micro grid here, and this micro grid can be connected to this larger grid. This we can have this, the large grid which I have written over there, can be understood as our electric supply system from what we have from our thermal power plants and hydro power plants, jo hamara usual larger power grid system. So this black diagram line here we have written as system interconnection. See, if you are not connecting to the grid, then it is an islanded mode. The whole microgrid is working as an island. It is not having any supply from this large grid. Then how is it supplied? It has a diesel generator or maybe more than one diesel generator. It can have one wind turbine, solar, photovoltaic cell, battery storage, and it has its own loads also. So that microgrid with all these generations supply to the particular load which have that local loads which it has. Okay, so but then what happens? The reliability the how much, because photovoltaic panels can supply only during daytime, wind turbine can supply only when you have wind, storage battery can finish the battery charge, can get over, or diesel generator you don't have fuel. So the situations can happen that these things are not there, then the islanded mode will have reliability problems. You don't have any supply, all these things got over, and the situations are in such a way that you cannot have anything else. In such cases, if you have a grid connected system, so that when there are you don't have any other source, this you can get the supply from the larger grid. So when you
Okay.
have connection, then it is a grid connected mode. So there is always an option. See, many a time what happens is in Leh, Ladakh and all, we cannot say that they don't have supply at all. They have supply, but the people there could not rely on that supply fully. So they have a microgrid of their own generation, and utilize that for the loads which they have, and the larger grid supplies whenever they require, when all these are not there or in such conditions.
Okay, thank you, ma'am.
Hope you got it.
Hello, madam. Good afternoon.
Yes.
Hello.
Yes.
I am Manish Kumar from Modi University, madam.
Yes.
In your third or fourth slide, you have written after microgrid, virtual power plant.
Yes.
So I don't understand how virtual power plant is connected with smart grid, madam. Can you elaborate at this point?
See, when we think about a power plant, we always have a idea that we have big boilers and thermal thing, coal is burning, and we have big boilers, and we have generators which generates, and then we have all those ideas in it. Now, when we think about a hydroelectric power station also, that is the main idea here. When we think about a virtual power plant, see, I'm not saying that we don't have all this. We have all this. You see, when we talk about a virtual library, it is not that you don't have any books. You have books, but then your utility comes. आप एक virtual library के बारे में जब आप सोचते हैं, what are we doing? We have all those books in the form of digital form, and you can sit and read it in the comfort of your room. That is the advantage of a library, virtual library. You don't have to go to a library, look for the book, pages palatna, read, you have to go through. In the comfort of a room, you sit and move your mouse and you read it. Similarly, for a virtual power plant also, that is a new concept coming up. Good question. Virtual power plant also, there are power plants, but then there are various distributed generations also. Now, what do the consumer require? He can choose. He can get the power from which power plant he has. So it is not that it is not physically with you, but you have the advantages of so many power plants on your computer table, or as a power management app. You have your own systems, distributed rooftops, photovoltaic, so you can take it from there, or you have wind turbine, you can take it from there. You have your own inverter batteries or storage, so you have an n number of power sources from which the consumer, or you can call yourself as a prosumer, can choose. So there is that environment we can call as a virtual power plant. That is what I have understood. That is the concept of virtual power plant, which we call as. Hope it is clear to you. Hello? Hello? Is it clear to you? We have virtual instrumentation these days, virtual instruments. We have virtual libraries. Similarly, this is an idea of a virtual power plant. Hello? Modi University का.
तरफ से हो गया था क्वेश्चन
Okay, so let me conclude my lecture. Smart grid provides intelligent, advanced power control for the next century. Many new technologies involved for supporting, sensing, controlling human interfaces. Electricity cost can be implemented similar to stock market in smart grid. See, nowadays it has come up in various countries in the world that there is an electricity market where you bargain for the cost of electricity, and like you have a stock market, you can have varying prices of electricity and you can bid for electricity and get it also. So that in having such a case, the consumer will be more powerful than the suppliers. There you have lots of supply, lots of power for you. Nowadays what we have a dearth of power supply. In such cases, when you have lots of power, the consumer is more powerful. You can have options to bid and take what you require. Similarly, there are powerful drivers taking us towards smarter or more intelligent networks. We have internet and all those facilities in now, which we are very familiar with. Same thing can be used in the electricity supply and generation and the grid also. So the concluding remark is that it has energy and operational efficiencies, high efficiencies and customer satisfaction. And in addition to that, the most important part is the reducing carbon emissions and thus have an environmental impact of it also. So hope I could do justice. You have any more questions also, we can discuss for some more time. Any more questions? Any other centers? That means we can break for the, if you don't have any questions, we can break for the day. We'll have classes tomorrow morning. Tomorrow morning we will again have a class on a detailed lecture on microgrid only by Dr. Y.P. Verma. With this input about smart grid, you will have more enlightening on microgrid tomorrow. So I told him today to give you more insight on the various researches going on in this area. So he will be giving you more opportunities, research areas which you can work on. If anyone is planning to do your MTech and PhD thesis, you can think of, you can ask him and note them down also. Then we have an interesting session on electric vehicles, hybrid electric vehicles, and how these vehicles in smart grid. I have given you a little bit input on that. We can have vehicle to grid supply and grid to vehicle supply also. So all this he will be giving. Dr. Mukesh Singh from Thapar University, Patiala. He has done his PhD research and all in this area only. He has various research scholars also working in this area. So you can have, I hope you have active discussions with him also tomorrow. So we'll break for today. So tomorrow morning, 10 o'clock, by 10, I request all the participants, all the centers,